Hello, everyone. Um, Welcome to day two of Hack Your Tech Career Summit. For those who weren't here yesterday, my name is Isadora. I am the program manager at the European Leadership University. Today, we will continue talking about different career pathways in tech and how to get started in tech. The summit is co organized by AI Agents and the European Leadership University. And you can find more about AI Agents and ELU by visiting the expo session. Um, Yesterday, we had people from all over the world interacting through the comments and amazing speakers. So please continue to share your comments and ideas in the chat screen. You can also ask questions to the speakers using the comment sections, and we'll try to answer it live at the end of the session. And to start, we have two very special people talking to us today as our first speakers. So it's time to introduce the founders of the organizing parties on stage, Alpert and Robert. Please join me.
Hello.
Can you both hear me?
Yes.
Yes.
Yes? Okay, good. So I'll start with you, Robert. Could you please introduce yourself and your company?
Yes, of course. Well, welcome from stormy the Netherlands. My name is Robert. Some people will know me probably from the LinkedIn groups that I'm running, the LinkedIn communities. I'm also a founder of AI Agents and co-organizer of this event. AI Agents is a career community for data scientists and developers. We have a job board and an event calendar. We have some skill tests and different communities where you can engage with other members who are working on the same topics or who are using the same programming languages. So I'm happy to invite you to have a look at aiagents.co, our website, or to join one of our communities. I will share some links a little bit later.
Thank you.
Right.
And
So
Alper, can you talk a little bit about ELU and your goals?
Yes. So we are European Leadership University. We are a new generation university built for the tech skills gap. We operate in Europe, and our goal is actually to offer affordable, flexible, new generation learning and job opportunities for young aspiring tech professionals. And we do this by um, various degree programs at the bachelor level and master's level, focusing on job roles like software engineering, artificial intelligence, data science, and and we do it only. We don't only do programs, and we do actually really learning journeys, which gives you the skills that you need to be successful in today's world. And we combine these skills with credentials and also with our employer partnerships, so that before you graduate, you get also to meet with the employers that are looking for skilled tech professionals for like you. And our programs are highly practical, not academical or theoretical. And our students are generally looking to reskill, upskill themselves in these new domains. And yeah, we're looking at reaching out to 100,000 students in next 10 years and placing them into jobs.
Nice. And you both were used to organizing local tech meetups in Amsterdam, but Corona's made you switch to online events like this. How was it switching to online events?
Robert?
Yes, that's correct. I was used to organize meetups in the Netherlands, in Amsterdam, and Utrecht, and I think indeed we organized our the first edition of this event in 2020. So that was after Corona hit the world. To be honest, I prefer to organize real life events. I guess most people will agree with me. But now that we have more than 1.5 million members in our communities, it's impossible to organize local meetups for everyone, for everywhere and for everyone. So in that sense, online events like this are a blessing. So it's a great way to bring people together from all around the world who are sharing the same interests.
Yeah, I
Nice.
think it's wonderful to be together face to face, but also it has a time cost, financial cost, and flexibility issues. So I love online events. We are an online university, and we use online at the utmost level. And I'm fascinated, for example, with this summit together in partnership with AI Agents. Now we can reach close to 1,000 people who can join from, let's say, 30, 40 countries around the world. Yesterday we had a full house, and speakers also from different parts of the world. So online has wonderful, wonderful features, and yeah, we'll continue to do online as much as we would do the face to face.
That's good. And Alper, how did you start your career in tech?
Well, I'm originally an engineer, so and my first job was with a French company, and I did a project on expert systems. At that time, there was fuzzy logic, which is the artificial intelligence 30 years ago. So it was really very, very different version of machine learning. So that was my, start of my tech career. Then I have spent the rest of my career for at least 20 years in skills development after that, and which is what I'm still doing. But I wanted to bring my original career, tech career, together with my, ongoing skills development career, and this is why I have been involved in the European Leadership University, and I'd like to create opportunities together with our team for young people in the tech domain with everything we've got and know on the tech field.
And what are the most important lessons that you both have learned in your careers?
Maybe I
Yeah, go
continue.
ahead. Go ahead, Alper.
I will. I think for me, what I learned is be brave, be bold, and be agile. Never get lazy, never postpone, and never give up. These are my lessons, and I always repeat that to myself whenever I'm stuck. And this is what I would say to aspiring tech professionals. You know, really be always open to new skills, new things. Never stop, and if you're challenged, never give up.
Yes, and dare to be different. And I think you should always follow or try to follow your own instinct. Of course, you should listen to other people, but that doesn't really mean you should always do what the majority of the people tells you to do. So really go follow your own instinct and your own dreams.
Yeah, that's that's good advice. And going back to the summits, why did you want to organize the summits, decide to organize the summits?
Well, I think it's one of the purposes of a community to bring people together and to organize events like this. It's also a pleasure and a rewarding thing to help other people, whether these are my members or the attendees of this event, to help them on their learning journeys and to bring or to move their careers forward. So it's really a rewarding thing to do and also a great experience for myself to organize events like this. I really enjoy it.
I think coming together is a big step. In tech, we need new people, new companies. We need to share our knowledge, our experiences. And when we started together with AI Agents, the summit idea in 2020, we started with few hundred people, and this group size, attendance doubled every year. And that shows me that there's a huge need to come together to discuss and to learn together. So I'm fascinated with the presentations yesterday and today, and I'm fascinated with the engagement of the audience and their depth of their interest. So we'd like to continue to create this platform and to offer this platform for tech recruiters, tech professionals, tech companies, and other companies who want to be in tech together.
Yes, I agree with you. And so you both were at the event yesterday, obviously. And so what did you think about it? What did you think stood out the most, or things you took away from it?
For me, I think it was not a particular talk or a particular topic or speaker. It was the mix of the mix of the different subjects and all the speakers with the different backgrounds. So we had recruiters, we had developers, we had content creators. So I think that really stood out, and I think all these people shared some honest advice and information and tips for students on how to start or accelerate their careers. So I think it's the whole program combined what stood out for me.
Yeah, I think for me, what really stood out is, first of all, the quality of the presentations and also the quality of engagement from the audience. So it was wonderful to be part of. And also, I could also notice two things. One of them is it's really important to go beyond the hype. There's this hype we hear about tech jobs and future and everything, but hearing it from real people and what to do, what not to do, and I think that was extremely valuable to hear. And I personally, being in this field, I learned so many new things. And also, finally, it's also really appealing to know that when you're in tech, you have so many opportunities, so many options. And for me, as a person, like freedom or being autonomous is a great value. And tech gives us this opportunity to be to be choiceful. So we can choose to be a freelancer, to be a developer, to work in a company, to start our own company, and it's all up to us. So to me, that's a wonderful field to be in that sense.
I agree. And I think the engagement yesterday was great. So I hope everyone that's here today continues engaging and asking a lot of questions, because it was very fun yesterday. And what do you guys hope to learn today during the second day of the summit?
I want to deepen my understanding of the tech domain again, and the the companies and what's needed and what is the trend, and yeah, that would be my objective.
Yes, today we have a great mix of speakers again. I think we again have senior developers, tech recruiters, influencers. So I think it's a great lineup. I will be focusing on the event itself. So I especially hope that all the attendees will learn a lot and enjoy the event.
Yes, I hope so too. I think it'll be great. And what do you guys think makes working in tech interesting to everyone that wants to start working in tech?
Well, I think a lot of things, of course, tech um, is the foundation of the future where we are going to live. It will impact so much things around us, and it can help us with a lot of problems that we will be facing in the future. So only for this, I think it's the most exciting. Well, tech is a very broad topic, of course, but it's, I think, the most exciting domain to work in anyway.
Yes, I think I want to build upon the impact and solving the problems. Definitely, that gives an ethos of tech for me. So you build something real and you solve real problems. I think this is wonderful. This also makes tech special in the sense that it's when you work in tech, you work with special group of people. So the people for me is definitely a big attractor. And then finally, as I said before, tech gives us so many options, so many choices, And this freedom of choice to me makes tech really a winner as you shape the future with great people.
That's nice. We have a really interesting question here from Reese. He says, "What does it honestly take to found your own companies or anything else? Is it really as intense as it's sometimes made out to be? How would one go about such a venture?"
Whoa, that's a difficult question here. I think um, I don't know if it's intense. It depends on how you start a company. You nowadays see a lot of companies who want to conquer the world like within a year, and they want to have funding for millions in the first year. And you can also start smart. Maybe that's even better, and don't have any investors running after you, and all these results you have to how do you say, well, all the results that you need. So I think it's better to start small. Of course you need some qualities and some skills, but I think it's especially about devotion and believing in your idea. And also it's a lot of fun, and there's a lot of rewards when you see your idea growing into something, even if it's still small. So I don't see it as intense or something. It's you have the opportunity to do what you want and to create something that's so rewarding that all the maybe negative things like stress or something, or they are minor to this.
Yeah. Maybe I want to build on what you said, Robert. I think the reward here, if it shouldn't be the financial reward, and I think it's too much for a financial reward because you sacrifice so many things. So for me, first of all, I don't see European Leadership University as, let's say, my own company, but I see it as a, a global community that I'm in the service of, and being in the service of something greater than myself, and seeing my ideas taking a place and shape in that service is great fun, as you said, Robert. And as I do that, being an apprentice of something new, learning something new, and growing with that is a great reward. So otherwise, I can always tell you, I think Reyes has a great point. You know, you be resilient and be that, be this. Yes, they are all correct, but in order to be all of that bees, we need to be in the service of a bigger purpose, and that should also serve us in terms of personal growth and learning and finding our own meaning. So that's where I get my strength from, a learning and meaning in what I do.
Perfect. I think we're almost wrapping up. So, last tips and advices, if you guys have any tips and advices for anyone that's hearing, that's starting in tech.
Well, stay tuned and follow the whole event today. There will be a lot of tips and tricks as well from all the different the people with all the different backgrounds. So you will learn a lot more than I can tell you now in just 1 minute. So stay with us.
Yeah. My advice, I mean, one of the hype things we always say, robots will take our jobs. I mean, or machines will take our jobs. And what I would say, just remember, machines will not take our jobs, but people with machines, working with machines, will take our jobs, and their jobs will be taken by people who can work with machines and people. So learn to work with people and the machines at the same time, and never stop learning.
Perfect. Thank you guys so much for your talk and for coming to talk with us, also, and for organizing the event.
Thank you very much.
Thank
And
you, Isadora, and
thank
stay
you.
tuned.
So, next up is Vincent Warmerdam. He will be showing us a live demo today, and we'll talk about how good algorithms lose against bad labels. So, welcome to the stage, Vincent.
Okay. Hi. So this is the mandatory audiovisual check setup. My screen is shared. Is that correct? Like, I don't see myself just yet. And also, just to check, on my screen, it all looks a bit pink, but can people see this thing that I'm drawing at the moment over here? I'm assuming so that's great. Okay, perfect. So hi everyone, my name's Vincent. Today is going to be interesting because I need to present with, the cat. It's probably going to be quite distracting. But what I'm going to talk to you about today is that there is a lot of hype in artificial intelligence and machine learning. And I can imagine if you're getting started, that's a little bit intimidating. What I want to explain, though, is that you really maybe shouldn't have to be that concerned about the whole thing because there are bigger problems that you probably want to be dealing with instead. To demonstrate what I mean by this, we are going to have a look at a data set that was released by Google. Now, Google is kind of well known as one of these big companies that seems to be doing a lot of AI. The impressive company, they hire a lot of PhDs, they do a lot of deep learning stuff. So, okay, probably a good company to pay attention to. They also release data sets once in a while. And that's meant for like academic institutions to help benchmark these algorithms that they might be interested in. In particular, for this data set, though, and I will have to move my cat to, yes, this is going to be very interesting. But the main thing that is of interest is that this is a data set where they try to detect emotion in text. So you got to imagine we have some text that is coming in, and attached to this one text, oh my God, yep, exclamation point. That is the final answer. Thank you so much. We might have the label of gratitude as well as approval. And the whole point behind this data set is that we are interested in having a model that can predict these labels, so to say. And this data set actually is, sorry, cat. Bye, Noah. But what's interesting about this data set is that they actually took a fair amount of effort to make sure it's a high quality one. So what they have done is they've actually gone through the entire data set from Reddit. That's where this data set was parsed from. They removed any reference to like an actual name in order to preserve privacy. So whenever a name of a person appeared, they paraphrased it with this little block over here. So, this is a pretty interesting data set, and people were pretty excited to do stuff with this data set. However, the moment that I see a data set like this, I'm also reminded of this project that you can find online called labelerrors.com. And the label errors website kind of looks like this when you enter. And the whole point of this website is to show how often label errors actually appear in these data sets. So for example, if you have a look at the ImageNet data set, then apparently this is a picture of a red panda. That is to say, if you were to believe the labels that are attached to the data set, that's what the algorithm is supposed to learn. And you can scroll down a bit. There's a couple of interesting examples, I think. So this, for example, is definitely not an ant. And here, this is definitely not a red panda. This is also not a bathtub. So like, these are the actual big data sets that people use to like claim that they have state-of-the-art performance and all that. But as I hope you're also able to just glance at this, like, hey, this is a bit tricky. How can I really claim that I have really good performance if the data sets that I'm testing it on might be broken? So I was wondering, we have Google that says we have a very cool Google Emotions data set that we're going to share to the outside world. We also have this label errors project that convinces me that maybe we shouldn't trust every data set out there. So that made me kind of think like, hey, can I play around with this little data set just to see if I can maybe poke at it a little bit and like how easy or how hard might it be like find bad labels in this data set? Because I can kind of do two things with this data set, right? I can either train a really good model, or I can say, let's just focus on the data quality first. So let's play with this. I'm using a Jupyter Notebook. If you've been doing a bit of data science for a while, and you'll probably immediately recognize the interface over here. And what I'm doing is I'm just loading in the Google Emotions data set below. So far, so good. And this is a data set that has lots of different columns. Let's just have a quick look at what the data set looks like. But basically what you get here is just stuff that was on Reddit. You have a column that's called text. And basically you have lots of different columns with labels. So it might be about pride, it might be about relief, it might be about surprise. And the goal is that we're going to detect all of these separate labels. But basically it's a text data set. So let's zoom in on a simple emotion that you might want to detect, just to keep it easy. And I figured, because this is a live audience, excitement is probably like a really nice and kind of more happy emotion to go for. We should remember that the data set we're using here is originally from Reddit, so anger might not be the nicest thing to look at. So we're going to go for excitement. And like examples are labeled as excitement, could be happy anniversary, exclamation point, heart emoji, so to say. Okay, so I'm kind of worried about bad labels being in this data set. Then you can wonder, well, how do you find bad labels? This data set is actually quite big, and it might not be the best, effort on my part to just go through each example one by one. Instead, I might be able to do something that's a little bit more clever. So how about this? What I'm going to do is I'm going to train a machine learning model. And the machine learning model will try to predict yes or no. And what I can do after the model is trained is I can ask, hey, give me examples where the label that's attached to the row doesn't match the label that is coming out of the model. Because if I sort of train a model on the same data that I'm trying to sort of guess on, then I would argue that most of the time the model needs to get it right. And if it has trouble getting it right, then maybe there's something interesting happening to maybe check. Another thing that I can also do now that I think about it is if I have a model that can predict a 1 or a 0, then it can typically also predict a probability between 1 and 0. So what I might also be able to do is use that to find examples where the model is just very confused. Every row where I get a probability that's like pretty much around 0.5, hey, yeah, those might be examples that are a bit iffy, that the model has a bit of confusion with. Maybe I got to check those first too. So that's basically what this notebook is going to do. We're just going to see if we can find some of these examples that don't really match the model expectations. So let's have a look at the first trick. The first trick that I'm just going to go ahead and do is this trick that's based around model uncertainty. And again, what I'm going to do is I'm going to take my trained model. I'm just going to say, hey, whenever the model's like around 0.5, then it's really uncertain. That's when I'm going to maybe manually check. And here's some of the first examples that I get when I do this. So apparently, that's adorable as F, which granted is like definitely something you might read on Reddit. It's internet slang, but it has an excitement label of 0. And this is a bit weird because I can imagine that that's adorable. It kind of sounds like excitement. I'm not sure if I really agree with this one. Then there are a couple of examples where I agree that's the correct label. So if there's a pattern, comma, yes, okay, excitement seems fine. But if I now look down at this example over here, apparently in this data set, oh my God, those tiny shoes, desire to boop snoot intensifies. I mean, yeah, I get it, it's internet slang, but this should be about excitement. I would argue that this should be label 1, not label 0. So just from doing this little exercise, I can already tell that something weird is happening to this data set. Like, I don't know if I can fully trust the labels. So let's try this other trick that I had. So this was the trick where we said if the model's uncertain, we're going to do something with it. But what I can also do is do this trick on confidence. And the idea here is that I'm just going to say, if the model is really sure about a label but it doesn't match it, then we're just going to sort based on that. And the first example that I see is I am inexplicably excited by some person's name. I get so excited by how he curl passes. I mean, this is an example where the word excited appears twice, but somehow the people who labeled this originally didn't think that adding this label would be appropriate. And these examples, oh my God, this is so amazing, exclamation point. Yeah, that should be excitement. And then, hey, congrats, that's amazing. You've done such amazing progress. Hey, yeah, that should also just be excitement. There's a bunch of errors in this data set, actually, come to think of it. I'm only looking at like the top couple of examples here, but already I have a little bit of distrust. Now, one interesting thing that you could do, like if you are a bit more inclined to the machine learning stuff, one thing that you could do is you could use different models. And I think this is a very interesting area of like work. So what you could do is you could say, well, let's use very basic count factorizer models to sort of predict the next, to predict the class. What you can also use is text embeddings. And if you have a model that just uses, like, does the word appear, yes or no, compared to something that's pre-trained on Wikipedia, then different examples appear also in this trick. So if I were to scroll down and if I were to say, hey, what are some examples with word embeddings that might be wrongly labeled, then I have a different model. And this model prefers shorter sentences. But also here, I just get so many of these examples where the label is just off, like by a mile. For sure, happy birthday, dude, exclamation point, that needs to be about excitement. And this is where dangerous territory starts to happen, right? Because you can wonder, if someone is telling me that they have the best model for a task, and they're doing that based off of a data set they found on the internet, how can we be certain it's actually performing well? Maybe if we want to guarantee that our models are actually learning stuff that's appropriate, we shouldn't worry too much about the machine learning model in the first place. Most of the learning happens in the labels. Maybe what we need to do more of is build systems that make it easier for us to double check that labels are accurate and that as the world is changing, we're not learning bad patterns. And that is something that a lot of companies don't really have a good process for yet. So there are some tricks, and this is like stuff that I'm working on. I've got an open source project that might help with this. So if you're in the market for a tool that helps you check your data, you might want to try out this thing called DoubtLab. It's pip installable. It's a tool that I made. Y'all might like it. And if you're curious for more, I also host this website called Calm Code. And one of the courses that are on here, besides just Python tools and everything, there is also a course just on bad labels and how to find them. So if you're interested in exploring this data quality space a bit more, this might also just be a course for you to explore as well. This was the main pitch that I wanted to make. Hope people take data quality serious, but I'll gladly take any questions that you might have now. I don't hear any questions coming in. I do see a question coming in from the private chat.
Hi, yes.
Hi.
So
Okay,
the question is from Anthony. Anthony, hello, sir. Which can you help me pick between Python and Java?
Yeah, I mean, the last time that I did Java, 15 years ago in college, and I'm assuming that the programming world of Java has moved on since then. I like to think that everything that I'm doing in Python now far exceeds anything that I was doing back in college 15 years ago. But I have no idea. I'm not able to advise you on which to pick. If I were to sort of give like any pointers in general, Python's great if you want to do machine learning. If you want to do production stuff in enterprise companies, then Java's better for performance and security reasons. I think I see a question coming in about the notebook. That's the next one that I can pick up. So Madison is asking, will your notebook be shared anywhere? The notebook is live. If you go to the Calm Code website, you will actually find all the code that I've just shown. But I believe if you go to my GitHub page, the name of the project is called Optimal on Paper. This was part of a talk I did called Optimal on Paper and Broken in Reality. So if you type optimal-on-paper, you're going to hopefully find this repository that has all of this code.
And then there's a new question from Jordan. What techniques would you recommend to deal with class imbalance? Can these be applied to both binary and multi-class problems?
Oh, yeah. And scikit-learn depends on the algorithm. But there are, like the logistic regression, for example, has a class_weight parameter. Many of algorithms in scikit-learn have this. I don't want to say every single one of them, but many of them do. And if you set that to equal to balanced, that typically helps out quite a bit. Class imbalance, I think the best way to deal with class imbalance is to just get more labels from the imbalanced class. Again, there are some tweaks that you can do in the machine learning part, but also here, maybe the data quality is the main thing that you're going to have to consider.
And then an anonymous question. Any idea on how to make labels non-subjective?
I mean, that's a really good question. So technically, I do want to admit in the example that I just showed you, also my cat agrees, there is some cultural attachment to like associating text with like an emotion label, so to say, right? So sure, I might have an opinion on what a label should be for a bit of text, but someone else might think of it differently. Same with sentiment. A lot of that is sort of nuanced. In the end, the best thing is that you are in a team, and then you as a team need to agree. So the best thing you typically do is you have meetings about this. One thing that I did at a client like a while ago is we had one team of domain experts and we had one team of data scientists. They would each label individually, like they wouldn't talk to each other while labeling. But then once a month, we would compare. And whenever there was disagreement, that would be like an item on the on the meeting, so to say. And that was quite insightful because then the stuff that the data scientists were worried about kind of got explained to the domain people and vice versa. But it's very much a conversation thing. A lot of labels aren't facts, and we shouldn't treat them as such.
We have lots of questions for you.
Grand.
So, how much effort goes into creating with and working with things like this?
You mean I'm assuming the person means the
You
Python
said,
package?
yeah, I'm
So
new to this, so forgive the lack of vocabulary.
yeah, so it depends on what you mean. So one thing, I've been doing this data science stuff for like 10 years. So for me, it's fairly easy to go from, oh, a data set to, okay, a Python package. So for me, it might take me like an afternoon, maybe like a day, maybe two, but not much more. But that's because I'm fairly experienced. To get to that level of experience, you might need 10 years. So I don't want to discount that experience really helps me in being productive, but I do want to suggest that there's a lot of stuff that you can do yourself. Like if learning Python might be better as a thing to focus on when you're starting out than to worry about how much time should I spend on something. As long as you're curious and as long as you're learning, you're doing it right.
Okay, good. Another question from Emmanuel. Are bad labels only with sentiment analysis or natural language processing? Is it possible to have bad labels without object classification, object detection, or just the traditional classification?
Take any data set, flip any label, and there you go. You will have a bad label. So in theory, any classification task could suffer from this. I will say though, like being able to detect whether or not something is badly labeled is much easier in like computer vision or text because a layman can just read it and confirm, oh yeah, this is supposed to be a different label. If you're trying to predict whether or not a user clicks on something, then it's much harder to just look at a row of data and to say, oh yeah, a user did or did not click in the past, and that's machine generated. So like playing around with bad labels and fixing them, I think that's a lot easier in text than in vision. But there are certainly some other domains because bad labels are just everywhere.
Okay, so for our last question from Guilherme, he said, how do you view the movement of data-centric AI put forward by Andrew and G? Do you think that's the future of AI?
I think the future of AI is hopefully going to be less hype. And I like to think that Andrew Un's first course contributed more to understanding than to hype. But what I'm a little bit afraid of with terms like data-centric AI is that we're just going to find another name for something that we can hype up. So it sounds reasonable what's happening there, and I'm happy to hear those kinds of things. But I want to be careful that we are not going to have products for data-centric AI and that we inflate lots of expectations. Maybe we should just drop AI and just call it data-centric. Like that would already be maybe a bit better. I do agree, though, that data quality is probably more important than anything else. But I do definitely agree with.
Okay. Thank you so much for coming and talking to us and for your live demo today.
My pleasure.
And now I am happy to introduce our next speaker. Her name is Julia Rutzkovska. She works at the tech recruiter Miro, and she will give you interview tips and tricks for software engineering. So the floor is all yours, Julia.
Hello, hi everyone.
Hi.
Let me see. I'm sharing my screen, but I don't know if everyone can see it right now. Can you help me with that? Just is it visible? Yeah, I think it is. Okay, perfect. Well, lovely to meet you all. Thank you for joining this session. Like Isadora said, I'm a tech recruiter. I currently work at Miro, but I've been enabling different organizations to hire and attract the best talent for past 8 years. And today I would like to talk to you about everyone's favorite topic, which is the interviewing. I know there's a lot of people having, of course, strong opinions around it. So the agenda for today would be going through the home interview setup. We all interview at home more and more, so just want to give you a couple of practical tips when it comes to that. And then I divided, no matter for what kind of role on a technical side you're going to be interviewing, if it's a software engineering, data scientist, or any other technical role, typically you would go for similar stages, like a recruiter or hiring screen, some kind of a technical assessment, and then a team round. So I'm just going to talk a little bit more about that. I'm going to actually help Isadora here as well and time myself too, so we keep a good track. So yeah, just to move to the first section. Obviously, interviewing, from home became a new reality, which sometimes it's great, right? It brings a lot of benefits. For example, you save a lot of time. It saves you lots of costs to traveling to the actual location. It also definitely helps you plan more, but it also brings some of the other disadvantages. So what we notice really a lot is that many candidates just book themselves back to back. I mean, I'm guilty of that as well. I think we all attend way too many online meetings. So if possible, definitely when you schedule your interviews, make sure that you have some time before and after the interview, ideally like 15 minutes, where you can get yourself and your mind in this interview mindset, and not just run from one thing to another. This is especially important when you're going to join any technical rounds where you really need to focus. Definitely would advise to do that. Another thing is, obviously, because we're interviewing from home, it's usually in the middle of the day. Try to pause your notifications. I know it sounds like a super simple thing to do, but we all forget, and it's so easy to get distracted by all the Slack messages, email notifications, calendar notifications. So in order to keep a little bit better focus, definitely advise you to do that. Another thing, if possible, I definitely recommend using some kind of a background. There's a lot of new kind of biases that we're noticing with many hiring managers. Like, for example, they might see a messy room and assume that you're not organized because of that. Obviously, we're all human, and you should not be judged upon of that. But I always feel the more you can help yourself, and this is the situation that you can control, just give it a try. Another thing that we're now notice quite a lot is that often people work with two screens at home. We've been at home for a long time, so most of us have a pretty professional setup. And often what happens is that the camera is based on the laptop like this, but then you would be having the view of the person that you're talking to on another screen. So usually when you talk to them, you're gonna look like this, which really gives a disengaged feeling, to the interviewers. And it's totally okay if you have a setup like this, as long as you manage the expectations and just say hey, just so you know, I'm seeing you on another screen. So if it looks like I'm not listening, that's the reason. I'm pretty sure everyone is okay with that. Now, another thing is obviously interviewing at home it can be a little bit hard. We're facing a lot of distractions that maybe you wouldn't have during the office interview. There are packages being delivered. There are families, homeschooling, pets, so many things that can happen. So just try to manage expectations if you expect any distractions, or if you are homeschooling on that day, or anything else that is happening. Just let the interviewers know. Like we're all been there. We're all in this situation for a long time. So I'm pretty sure everyone is okay with that. And then last not least, from the bottom heart of every recruiter out there, wear pants. This happens quite a lot. You definitely don't have to suit up for the interviews nowadays, but any kind of pants is definitely appreciated. Now let me move to another part. So like I mentioned, no matter what kind of interview you're going to attend, usually there is some kind of screening, right? Whether it's a hiring manager or recruiter, you're going to have this initial conversation. So a couple of tips when it comes to this part. First of all, like check the basic information about the company. I know, again, this might sound very basic, but you would be surprised how many people are applying for jobs, go on an interview, and have absolutely no clue what the company does, what is the product. It definitely buys you some extra points. And there's they've done a research on that, and approximately 50% of recruiters would reject a candidate that has no idea about the company that are applying, which I'm actually surprised. I would think it would be even higher, but it does happen a lot. Be prepared to talk about your motivation, why you want to work why did you apply, right? Of course, you want to get some more information, but just to talk through the application and your motivation always helps us understand, your commitment. And that's not the same as why do you want to leave your current job, right? So just be prepared to talk about that. Now, another thing would be prepared to talk about things. They're always sensitive, and I understand that, like package or relocation. You don't have to talk about specific numbers. No one can ask or should be asking you about your current compensation, but I'm sure there is a certain, level that you would want to reach. And the more you share, the better chance there is to reach the agreement at the end of the process. Also, if you're in a process with other companies, this is definitely the moment to let the company know. Most of the companies will really try to time their process, and if they're excited, they're definitely going to do their best to schedule their interviews as soon as possible to make sure that they can compete with other companies out there. And be curious, prepare some questions. This is again the opportunity for you to learn more. This is a recruiter will usually give you a lot of information about the company if you ask, and that also shows a certain level of engagement. So definitely advise you to do that. Then the next stage would be typically some kind of a live technical assessment or a take-home technical challenge that differs per company. So that, but for most of the interviews for the technical roles, you will have stage like this. A couple of important things here is, one is definitely the time management, right? If you're going, for example, into a live coding session and it takes 1 hour, be aware that it's most likely going to take 45 minutes to code. You're still going to have questions. There's going to be introductions, right? You might want to ask something. So definitely just bear that in mind when preparing. We often, because the communication is another part that is being assessed during this kind of rounds, Definitely encourage you even to practice at home while talking, which might be a little bit distracting and a little bit awkward, but it definitely helps, especially with the time management part. Another thing that would be important is asking clarifying questions. And if you're making any assumptions, that's absolutely okay, but just make sure that you communicate this, that you let the interviewers know that this is your assumption and this is why you would like to this or that. Most of the interviewers will be allowed to give you feedback and help you out. So definitely stay open to their feedback and listen what they're saying. It's an awkward situation for everyone if the interview is going really bad. So most of the people want you to succeed. They want to help you. So let them do that. Definitely helps. Now, another thing would be what I mentioned before, especially if you work on 2 screens and you have some kind of a technical assessment, flag it to the team, because if you switch really a lot for 2 screens, you might get into the situation that some of the interviewers would assume that maybe you're just, Googling the solution on another screen, or that you're not clearly focused. So just manage their expectations that this is where you're doing it. Practice really makes perfect, and that's I know it's hard. It takes a lot of time, the preparation, but definitely, especially when it comes to coding assessments or any kind of live technical assessments, just Googling them, trying them out. There are a lot of platforms out there like Codility, like Code Signal, like HackerRank, that have a lot of questions, that you can use from the bank to practice. Now, what is really important as well is, you probably, if you practice a lot, you might find yourself in a situation where you might know the question. What to do in this situation is always a tricky thing, right? I'm not going to give you a fixed answer, say it, don't say it. It's your choice what you're going to do. Just be aware that if you don't inform the interviewers that you know the question and then you solve it within 5 minutes, that might seem a little bit suspicious. And also they might give you then another question that is going to be much harder, because they think you did so great on this question. Let's give another harder question. So just think, what do you think is best to do in this specific situation? If there's any take-home test, or any thing that you will have to present to the stakeholders, just make sure that you practice at home as well. The last part would be a team part usually. So couple of tips I have for this round. Most of the companies are going to use behavioral or situational questions, mostly behavioral. So get familiar with the STAR method if you're not familiar with it already. Check the values of the company. A lot of companies are really proud of their values and they structure the team interviews around their values. So a lot of questions are going to be linked somehow to the company values very often. Read your audience, of course. I know it's much harder to do it on the screen, but still, most of the time you should be able to see whether they're following, whether they're nodding. So definitely try to adjust. If you don't understand the question, which can happen, or you're not clear what they want to hear, just ask. It's okay to clarify it, just to make sure that you're on a good track. Always good to think of some examples of good collaboration, or maybe mistakes that you made that you learned from. That's something that often will be asked during interviews like this. And the last 2 things, I would say, ask questions. I mean, interview is a great opportunity for you also to interview the other side, right? It's a 2-way street. You also want to know whether this is a good fit for you, whether this is the right team, the value, the culture. So definitely use this opportunity. I'm sometimes surprised how little questions people ask during the process. That always worries me a little bit, because I think if you're really serious about the change, most likely you want to find out as much as possible. Last not least, be yourself, right? At the end of the day, you're going to be joining a new team and you want to feel comfortable. You don't want to pretend you're anyone else. So definitely, just show them who you are. And if for any reason that would be, the reason for them not to have you on a team, then that's probably also not a team that you would like to be a part of. And just in general, to summarize it all, like I mentioned, it is a two-way street, right? So I know the processes in some of the companies, especially tech companies, can be very lengthy and it costs a lot of time and preparation. But just try to think about each of those touch points, as interviewing back, as seeing whether this is the right opportunity for you. And if you see yourself at this company. So I guess that kind of sums it up. It's a very big topic. I could be talking about this for hours, but because of the time constraints, I'm just going to stop it here. And if you have any questions, just feel free to ask.
So there's a question from Reese. What would be the best way to deal with apprehension and anxiety when going into an interview, especially for those who have social anxiety or generalized anxiety disorder?
Yeah, I think it's a very good question. I think one thing is like prepare your environment as much as you can to feel comfortable, right? There is you're not going to be able to control all of it, but just make sure that the part that you can control, like your setup, that you feel comfortable, that you sit in the right place, to make it as good for you as possible. And then also be honest, to be you can be transparent. A lot of companies will understand this and will be open. So we have a lot of candidates that just say, I'm really nervous, and it's okay. It is a stressful situation, right? Changing jobs is apparently the third most stressful event in people's life, and it comes even I think before getting married. So definitely, be honest.
Okay. And another question that I have is, after after you have an interview, is it okay to ask for feedback?
Absolutely. Yes, you can always ask for feedback. I will be honest that some of the companies have policies where they're not allowed to share any written feedback, for example. But I would definitely ask for it. I think still a lot of recruiters are out there to do it, and we definitely want people to have a constructive feedback to work with.
And also, if I don't know if recruiters think it's fine for people to ask for a time frame for a reply on
Absolutely,
their
keep us
interview.
accountable.
Yes,
Yes,
exactly.
you can definitely ask for the time frame. It can sometimes be, of course, that the time frame gets longer, but you still should get at least an update, on how the situation is going. So absolutely ask for it.
Okay, perfect. And do you think, in how long do you think it's an appropriate amount to wait before reaching out? Or
I would say it depends on the round, and it depends on, for example, if you completed the full process, then typically, if there's been a couple of interviews, usually we would need to schedule a debrief and bring everyone together. Of course, usually we want to do it as fast as possible. For us, it's also important, of course, to keep the momentum. But that might take a couple of days. After some interviews, it can be a day or two. I would definitely, I think after a couple of days you can reach out, unless the recruiter manage your expectations that it's going to take longer.
so I think that's it for I think our
No
time is
worries.
up. Thank you so
Thank you
much
so
for
much.
your tips. I think everyone is going to benefit a lot from them, especially coming from a tech recruiter. So thank you for coming here. And
Thank you.
so for our next speaker today is Alvaro Cavalero from Data Snipper. Alvaro is the head of people and will tell us what are the skills required to become a software engineer. So, welcome. You're on mute, Alvaro.
Of course, I am mute. Sorry, everyone. Good afternoon. Really happy, really excited to be here. Thanks for the invite. As mentioned, my name is Alvaro Caballero, originally from Mexico. An engineer myself, although I didn't quite practice as an engineer a lot. As a way of presentation, kind of like showing a bit of my experience, I was the head of the academy for a couple of years for ING. So I was responsible for supporting the learning and development of the global engineering workforce at ING. And it was a fantastic experience. And up until a few weeks ago, then I did the move to Data Snipper as head of people, a very exciting company that is growing like crazy. We're a scale-up based in Amsterdam. So here today, I will try to discuss a bit or share a bit my experience on what is it that organizations are looking for for those who are studying software engineering or who want a career in software engineering, right? So that's a little bit of what I wanted to show today. And I'm going to mention 3 things because I only have 15 minutes. The first one is you should start looking ahead on how are you going to be evaluated on your career ladders, right? Luckily, we live in the internet, so there's a lot of information available, but it all starts with understanding your career journey, right? At the end of the day, you can actually start preparing. Once you know the career you want to pick, what are the skills and competencies that are going to make or break your career path, right? As a practical advice, there is this wonderful website called progression.fyi. A lot of organizations are putting their career growth or competency frameworks available. It is for free. Quick note, some of them are out of date. It doesn't matter. At the end, what it matters is that you get to see specifically which skills and competencies matter for a software engineer, right? Super important to keep in mind. Most of those are based on the Dreyfus had a typo here, sorry. The Dreyfus model of skill acquisition, which basically looks at the path or the arc of development of a competency from novice to advanced beginner to competent to proficient to expert, right? And a lot of this growth or career ladders, they're based on around this model, right? What is interesting to look at if you get a look at this type of examples, you start seeing some patterns, right? And that's actually what I want to discuss with you today. They are not only providing you with the requirements of the technical expertise that you need, because it changes with every organization. They have very specific tech stacks, very specific legacy situations. So what technical expertise is needed can vary a lot. But most of them, they include also non-technical expertise, which is, according to my experience, just as important for you to develop. So basically, my message today to you is I want you to focus on 2 of the skills that I consider the most relevant for a software engineer today, that I can tell you with a lot of high degree of confidence, if you build, you will have a good shot at a successful career from the start. What are those actually? Well, the first one is excellent writing skills. Now, as an engineer, that is not always expected. But it is a crucial skill that you need to start building from today, because it's not something that you can do switch on and off or watch a tutorial and then you become a good writer. Right? So it needs practice. So now that you're building your career, this is the moment to start. Now, why? Well, first of all, clear thinking is clear writing is clear thinking. At the end of the day, if you can explain in writing everything that is on the problem and the solution, you'll get a lot more chances of being inviting to your colleagues to solve it and get inputs that actually make a difference on the solution that you offer. And the other reason is because in today's world, when we have a lot of asynchronous way of working, a lot of remote working with colleagues in many locations, discussing a lot of issues through Slack, through Discord, through Teams, Of course, writing skills become not only important for solutions, but it's also the way you actually communicate with everyone in your organization matters. And those who stand out with their writing skills get noticed. I want to make it practical for you. Here is an excellent website in which you can find a lot of information. Sorry. It doesn't show here, but you can look for Gergely Oros. He has the Pragmatic Engineer website, and he has a fantastic list of resources and advice on how do you become a good writer. Okay, so that's one thing that I want you to keep in mind. To build on this, don't take my word for it. Amazon is famous for ditching the whole PowerPoint format and pushing their executive meetings with a 6-page memo, right? And in this book, high executives from Amazon, Colin Breyer and Bill Carr, actually explain a few reasons why you should look at narrative over the famous PowerPoint presentation, right? And that is a little bit of the writing culture that Amazon is trying to push. As another example, Stripe is pushing the writing culture. So you see at the forefront of technology organizations, writing is becoming super important. So a few reasons. Decision making requires narrative. Now, it is a lot more fancy to have a presentation with nice slides, but if you want to have thorough decision making, if you want to pack a lot of information density, use writing. It allows you, the format allows you for a lot better way of explaining what a situation is, what are the potential solutions, right? Another idea that comes with writing is that it relies less on charisma. You know, you have all this idea of the good speaker with the beautiful slides that engage the audience. Leave that for a tech talk. When we're talking about technical decisions, complex decisions, team decisions, you need to make sure that your ideas get the spotlight, not your charisma. It allows better analysis. It allows you to build a shared understanding because everyone get to read the different points of view that are put on the writing. So there are many ways in which you can take advantage of the writing structure. And finally, yes, here it is. The Pragmatic Engineer. He writes a lot about tech. He's actually based in Amsterdam. I recommend you to follow him on Twitter or to subscribe to his newsletter. And then he wrote one specifically of becoming a better writer as a software engineer. A lot of fantastic advice that he shares there. Actually, this is a copy paste from his website. Some of the tools that you can start looking, Grammarly Pro. If you're already working and you want to build quickly your grammar, just use Grammarly Pro. It's a few dollars a year, and it actually makes a lot of a difference. Hemingway Editor, the same, a little bit, making easier to structure your writing. Some books that he recommends: On Writing Well by William Sincer, one of my favorites, Dreyer's English, and The Element of Style. And of course, there's a bunch of free online resources, so there's no reason why you cannot already start looking into this and start practicing. The Writing Well Handbook by Julian Shapiro. Particularly recommend Technical Writing Courses by Google and The Craft of Writing Effectively, right? Those are free resources. Again, this is provided by Gergely, but I can subscribe wholeheartedly to what he mentions. So tip number one for you, take a look at the career ladder so you can start looking at what are the skills that you might need and you start working on them today. Tip number two, you need to start looking at excellent writing skills. It is super important. Now, tip number three, practice decision making. This is something that we see over and over again. Someone with an excellent stack of knowledge, technical skills, leadership skills, all of a sudden, when faced with a lot of the type of decisions that they make, they actually struggle. And this is because we're not learning to be systematic on the decision making. It's an art and it's a skill that needs to be built, right? And here's the thing with decision making. Oftentimes, we look at decision making and we evaluate that decision making, whether it was good or bad, based on the outcome, right? If it was a good decision, we're going to have a good outcome. But guess what? You can have bad decisions and through luck, have a good outcome. Or you can have really good decisions and through luck as well, or to unforeseen circumstances, you can have bad results. So my point here is that result is not the best indicator of good decision making, right? So what is a good decision making? Well, it is to structure your thinking as a process, being systematic. There are different approaches, different ways to look at decision making that actually ensures that you raise the bar on how you make decisions, and then you raise the probability of having good outcomes. Again, this is something that we don't really learn at school. And so part of my message today is start practicing, right? Of course, you cannot apply very complex decision-making techniques for things that are very simple for our day-to-day life. But start thinking about those allows you to embed that reflex, that habit for you. So one of the first ways to look at decision-making is to think in terms of mental models. Like, so mental models is kind of like a representation, a desimplification of how the world works or how a situation unfolds. And there are plenty of mental models right now, and there's plenty of stuff available. Start thinking mental models like second order thinking, right? So start asking yourself, when you have to make a decision, instead of going to the first direct outcome, start asking yourself, and then what? And then why? What will be the situation if this happens? So start creating those sort of like ramifications of your decision, so you can get to the second or third order effects. Okay, this is a very simple technique, but we usually don't use it. It's incredible how often you ask engineers, how is it that you came to this decision? And they stay on the first order technique. Another good tip is regret minimization, right? Try to make a decision, and then you make the decision based off what is the thing that you will regret the most if you do or you don't do it. Or the other one is inversion. Instead of looking for 100 reasons why your team can be a great collaboration team, start looking at, okay, what will make it a really bad collaboration team? Again, these mental models are fairly simple, but you start building this toolbox of mental models, and you start thinking on the resolution of the problems through different angles. By being, again, systematic of applying all these little models, you are sure that you're closer to a better solution, okay? Of course, I want to make it practical for you. Here is my top 5 resources for mental models. They're all for free. Spend some time reading about them, spend some time trying to practicing them. First one is Scott Young. The second one is James Clear, who wrote the book Atomic Habits. Then we have Julian Shapiro, which was mentioned before as well. Julian Shapiro has an excellent couple of resources on mental models. And Laure Lecomte, also from the Nest Lab website, really good recommendation. And from my perspective, one of the best in terms of thinking and mental models is Shane Parrish in his blog Farnham Street. So wholeheartedly recommend every single of his podcasts, every single of his free blogs. He wrote a book with mental models as well. So if you can afford it, if you're interested, please buy it. And as an extra, he actually created this course, which I already took. It's called Decision by Design. I promise he's not paying me to pitch this, but I found it one of the most interesting courses that I ever took. Right now, they're not taking any more sign-ups, but you can sign the waiting list, and whenever that comes again, I definitely support it. Of course, this is a paid one, but it was amazing because it really makes it practical and very thorough. So I think I'm hitting the 15-minute mark, which is what I wanted to. To recap, career ladders, and look for those skills that you are going to be evaluated so you can start preparing. Number 2, a lot of writing. Practice your writing. There is no shortcut. You need to start practicing. Clear thinking is clear writing. Remember that. And number 3, be systematic and build the habit of using mental models on your decision-making process. So these are my 3 tips for you. There's a lot more that I would love to talk about, but I want to keep it really tight on that. I don't want to leave some minutes for questions now.
Hi, Alvaro. Thank you. We have a question from Nicola. She said, "Hello, I'm interested in Mr. Alvaro's opinion on the Python Flask Django learning path."
The Python Flask Django learning path. I don't know. I'm gonna be absolutely honest with you. I don't know how easy it is. I know for sure that, for instance, at ING, there was a lot of interest on Python because it applied to multiple things, from data engineers, data scientists, hardcore engineering developers. I don't know what exactly is it that you would like me to tell you there. Here is what I would tell you as I was speaking during my talk. These particular paths, these particular learning paths are very dependent on what tech stacks those organizations have. So part of your decision whether or not to evaluate this as a good learning path is it relevant for the type of career that you want, and that you can link it to the type of career ladders that you're looking at, right? So I cannot evaluate particularly this one, but I can tell you, do not always think of the latest combination or the latest framework to learn. Makes it more, is it useful on the career path that I need?
Thank you. And we also have another question, anonymous. What do you think that is the most important skill that a potential software engineer shall focus on developing?
The most important skill, well, I honestly believe is between writing and decision making, and that's what I try to explain today. Those are two skills, and let me tell you why. And I probably will pick writing, and not only because it's, as I mentioned, very is super needed in the type of work that we're doing today, but also think about it this way: engineering work, software developer work, they're always dealing with abstractions. Right? Like, so we're really knee deep on how do you abstract to solve a problem. And sometimes, or a lot of times, being able to drop that way of thinking, all that way of trying to solve that problem, keeping a lot of abstractions and things in mind to solve your programming challenge or your engineering challenge, and you need to move into the realm of simplicity. How do you simplify your argument so they're actually convincing and solid? So it's not necessarily the same skill there, and very often we see engineers who are really gifted technically, but have the hardest time to simplify their thinking in a way that becomes effective. And at the end of the day, if you're part of the team, this is what you need. You need to make sure that your ideas are recognized, are understood, are picked up on, and you can drive change with excellent writing skills.
Okay, good. And then Clarice asked the question, is this the right resource for the pragmatic engineering blog? It's blog.pragmaticengineer.com.
I believe so. Yes, I believe that's the one that should be there.
And then another question, anonymous, is what do you like in being a software engineer?
I'm not a software engineer. I'm a mechatronics engineer.
Oh.
And I have to say, the part that I've had the most struggle with as an engineer was the development. Like a mechatronics engineer, you have this combination between electric engineer, mechanical engineer, and software developer. Software developer was the weakest point for me, and so I enjoyed learning the basics, C, Java, and a few others. But then I enjoy a lot more the combination of electronics, electric, and mechanics.
Nice. I think that's it for the questions that we have for now. I don't see any more questions coming in. So that's it. Thank you so much, Alvaro, for talking to us and giving us this talk. It was great listening from you.
Super welcome. Available. I'm available. You can find me on Twitter. You can find me on LinkedIn. Super happy to follow up this conversation.
Thank you so much. You can also be part of the chat if you want after.
Thanks a lot.
So for our next speaker, I think Greg is already here, so I'm already going to present him. We have Greg Hogg. Greg is a data scientist, and he also has a YouTube channel with more than 16,000 subscribers, where he teaches people about machine learning and data science. And he will talk about how to become a data scientist in 2022. So welcome.
Yeah. Thank you. All right. So I did see some questions just previously, a little more into specific stuff about like Python frameworks. And so I might be a little bit more knowledgeable about that piece. Of course, I'm not an engineer, so all of the all the more engineering things I would not stand a chance at. But maybe we can try those questions. I can give a different approach to that anyway. So thanks so much for the introduction. And yeah, so am I sharing my screen? I'm just seeing me, which is kind of there we go. Okay, so yeah, we're going to talk about how to become a data scientist. And firstly, I need to convince some of you that it's a good idea to do that. So quite seriously, where am I? There we go. Okay, so why? Well, it's a very simple picture here in Word, interesting, but quite genuinely, I was really happy. I've worked in software, some silly high school jobs, which you really don't want to do. But data science by far is the thing that really just made me happy and wanting to wake up is every single day, like solving genuinely interesting problems that people need to get solved. And there is, of course, a variety of fields you can do that. But also, it has all of those lovely perks of if you want to be like a remote worker and you want to just kind of wake up and be on your laptop, then data science is probably suitable for that. Of course, there's some more physical type jobs where you might be go more into the engineering side as well. But in general, I absolutely love it, and we can talk more about the specifics. So, of course, associated with anything that takes a lot of hard work, you are going to get a high salary. Most likely, there's some caveats where you might get, probably many of you have heard of this like data science hype in the last like 10 years or machine learning, and you might fall into a trap where these employers are advertising a job as data science, except it's maybe a little bit more on the basic side, and so the salary is a little bit less. But in general, for what I consider and most people consider a data science job to be, you are going to get a pretty good compensation, most likely 100K or more or something like that. So I'm going to zoom into this interesting thing, just some broad examples of what data science could be. And that also, I'm just going to show one example so that makes more sense. Of course, one of the big hypes is self-driving cars. Elon Musk and Tesla really pushed a lot of that forward and doing a great job there. There is still a lot of positions in that. And of course, this is just a one very specific example, but really what we're talking about here, and to show another example, is medical imaging. It's understanding what is in pictures. And that really transitioned in the last 10 or so years from people doing these traditional really specific techniques for, oh, I want to look at medical imaging, I'll have to study that a lot, or oh, I want to do self-driving cars, I'll study that specific piece a lot. All of these different pictures I'm going to show, like say speech detection or forecasting, or this is a little bit more tricky and specific. Autonomous robots, for example, these ones are playing soccer. It's probably doing something called reinforcement learning, which is very phenomenal, but a little bit more difficult to get into. All of these different pictures here and techniques, they're really all of the different things that you learn. Just if you get an undergraduate degree in statistics, and we'll talk about the education, or if you take, I think about an hour ago in the presentations, someone brought up the engineering machine learning course. That is the stuff that teaches you pretty much most of what you need to know for these, and you will at least be considered for many of these different jobs if you know we'll talk about deep learning essentially has taken over. Okay, so going into, yeah, basically anything with data. This is just a spreadsheet, but you can, which is the most common thing in businesses. You're just going to get like an SQL table, and we'll talk about that very soon. But really, a picture, that's data. A video, that's multiple pictures, that's data. Speech, text, all of that stuff. If you get used to making predictive models with data, then you can do pretty much anything you want. So, jumping into a little bit more of the specific common skills that I called it common because, as actually the last speaker is talking about, it's not so much so about the actual framework or technique that's being used. It's more so about what you need to get the job done. But what is very common, and what I'd recommend for sure, is say SQL. So it stands for Structured Query Language. It is simply sort of kind of a programming language. It's a programming language with a very specific task of manipulating tables. So if we saw like this spreadsheet here, it would be for doing sort of transformations on this data set. So you need to get used to just manipulating data, and SQL will mostly you'll be doing it first selecting and pulling data rather than pushing and actually manipulating the database itself, but all of that is very useful. So programming, it's specific, so a conventional programming language. But what I put here is Python, R, and Julia. Those are the three languages that make up, if you've heard of Jupyter, it stands for Julia, Python, and R. And those are really considered the three data science languages right now. Of course, you can do other stuff, and many programming languages are still ridiculously like abundant, like Java and C++ are still not going anywhere anytime soon. And of course, you can do data science in those type of languages. Something you might see is Scala, which is mainly used because of something called Spark, which I forget when we talk about that. It might be the next thing. Well, yeah, okay. So analytics, transformation, statistics, and visualization. That we'll talk about something called Spark very soon, but essentially that's a way to manipulate big amounts of data. If you heard the word big data, really all it means is if you have this spreadsheet here, it's a lot of different rows. Like, I've been asked, like, what does big data mean specifically? 1,000 rows, probably not. 10,000 rows, getting closer. 100,000, a million rows, probably approaching what we consider to be big data, which just means you use something like Spark, which we'll talk about. Okay, so anyways, you need to have, so here's the main or first three skills here. Manipulate stuff with specifically SQL is most common, actually programming, analytics, so just the statistical techniques behind that, all of the graphs, and it honestly doesn't take that much skill. There's a massive buzzword about like data visualization, or for some reason we're even calling it like data viz, which I think is really silly. It's honestly just kind of looking up scatter plots, which is plotting things X and Y, or very similar to a scatter plot, like a forecasting line over time, and bar charts and all of that sort of stuff. If you get used to those, and the coding is very simple for it, in say Python or R, you literally just write like scatter plot and pass in the data. Of course, there's more complicated techniques, but it's good to get used to that stuff. The more complicated pieces are machine learning and statistical learning. Those mean exactly the same thing. So something that was tricking me up for a while is like, people are always recommending this book called Elements of Statistical Learning, or Introduction to Statistical Learning with R, versus machine learning itself. And they mean literally the exact same thing according to pretty much everybody that's well versed in this area. Okay, so very important, because that is what allows you to make predictive models. Given data, we can learn about and try to make predictions about the future. And basically a subclass of the machine learning and statistical learning is deep learning, which is just kind of more like a bigger model, and generally a non-linear model, which some of the statistical learning type techniques might be linear, which means they draw kind of simpler curves, or not even really curves, they more so draw lines, but not going to get into that. You want to learn deep learning because they allow you to solve pretty much every problem that we saw over here. Like any sort of model you could make with the spreadsheet, probably could use a neural network for that. Autonomous robots, you'd probably use something called reinforcement learning with neural networks. Forecasting, you can use something called an LSTM or CNNs for forecasting. Speech detection, probably like an LSTM type model. Medical imaging, CNN, all that sort of stuff. I'm just listing acronyms, which I wouldn't expect you to know. They are just simply types of neural networks, so deep learning techniques. So education. Here we have, say, a bachelor's degree in computer science, mathematics, or engineering is recommended for sure. To be honest, it can be a little bit tricky to jump into the field without actually having some sort of a degree. You can, but I generally recommend that if you can. A master's degree or PhD doesn't hurt. I wrote doesn't hurt as in if you are on the edge of whether you should do it or not, probably go for it, and it's a good decision. It just might not necessarily be a requirement. It might be a requirement for some jobs as well. And the reason I put requirement in quotes is because it might be claimed to be a requirement, but it's honestly not really, because as soon as you get in contact with a recruiter, they're like, yeah, we don't actually care if you have a PhD. Clearly, we're someone that you want. And so requirement, it's that word is kind of always in quotes when you're dealing with people, because you can fight around some things, but you can't fight around computers. So sometimes, like I know Microsoft in particular, they will immediately cut you off for many positions if you don't have a link to a publication from like a PhD or master's or something like that. And so sometimes it is really a requirement. So what math in particular? That's a common question of what mathematics do you need to know or should you know? And it's tricky because you technically could get around it without knowing much of anything because all of the stuff is abstracted in the programming languages, like TensorFlow, for example, is for making neural networks. So do you really need it? I honestly still argue yes, and I'll argue these points of the basics. When I capitalize that, it reminds me of the language basic. I mean, I just mean emphasizing the basics of linear algebra, calculus, optimization, and probability. So notice here that I did not write the word statistics, even though that probably underpins everything, because I would say intermediate theoretical knowledge in statistics, so like regression, classification, forecasting, which again, I used the word statistical learning or machine learning before, and I would definitely recommend that's pretty much what I mean here. So just looking at these points here, linear algebra, calculus, optimization, and probability, the basics of those is really because machine learning almost always bottles down to just numerically, so approximating the solution to some problem, which means you define some model. Maybe it's like a linear regression or something really complicated like a neural network, except we're just using linear algebra, calculus, optimization, and all of this stuff to optimize the problem, which just means fit the data. We're trying to make a model that accurately gets the trend of the data so that given new data, we can make accurate predictions about that data. And of course, all of those different prediction techniques, that is what is in the statistics area here. So how to stand out? How do you actually, look better than other candidates? Because I talked here, if I go back to just these points here, education, get a bachelor's degree, SQL, deep learning, those are, relatively standard, and it's still a lot because, like, to become a data scientist, it's definitely a lot, but it's not necessarily enough to stand out in particular. So I would stand out with very strong programming skills, like web development, APIs, and mobile development. Spark and PySpark is, I'm not going to explain too much about what that is, but essentially it is a relatively modern framework or set of tools that allow you to transform data very quickly. Either a few very good projects or many projects. Although I didn't really give myself much of an introduction because I want to just, get on with the good stuff. My portfolio is really a bunch of good projects. Like it's YouTube and LinkedIn, which is just showing pretty much everything that I know onto. If you go to visit my socials, then you can see everything that I know. That's not the only technique. You can definitely have a few very good projects, which is excellent for a resume because then you can just actually describe those projects on the resume. I actually don't include projects on my resume anymore because I simply leave that up to YouTube and LinkedIn to if the employer goes to that. Research publications is something that may be a requirement and is incredibly helpful for any areas of machine learning. And individuality. I wrote that 3 times. You really just have to be you, and I'm going to stress that a little bit more on this next page. So, do what makes you happy. Those are really the same points there. If I go back, individuality and do what makes you happy, the rest will follow. Seriously, like just wake up and do what you want to do. If it genuinely isn't data science and you've given it a fair shot, you've fought through some of the more annoying pieces, like, you spent 10 hours trying to set up your virtual Python environment or whatever. If you fought through all of that and you kind of get a feel for it and you still don't really like it, well, then you probably shouldn't do that. If you do like data science, but you don't like studying it the way that I told you, like, for example, if you see one of my YouTube videos on like my Coursera pathway to learning all of this stuff, just a bunch of resources to follow one after the next. If you don't like that, then please don't do it. Learn how you want to. Take your time. I get asked a lot about like, how long is this going to take? Like, if I study 24 hours for the next month, am I going to be a data scientist? I don't know. Like, are you good at math? Have you done a lot of this stuff before? It's very rude for anyone to give you a sort of pathway with a fixed time constraint saying, hey, you should be able to learn all these things in this given time. Take your time. And if you really need a high paying job, well, then, work harder, work faster, keep the pressure off though. Seriously, pressure is not good. and all the competition between friends, which is this point here. Ignore everyone else. I went to school, or I'm just finishing up school at the University of Waterloo, which has very well known for a competitive co-op program with your friends that are always telling you about their awesome jobs, and it can be positive. Like, it can push you to know that you can achieve the same things, and everybody here can, regardless of your university, really, or if there is no university. Um, but it can also definitely be negative, where you just physically start thinking about what they're doing, which is a waste of time, and definitely all the emotional aspects are not good. I want to start with an easier job. So this is how to become a data scientist. You might want to start by becoming, say, a data analyst, which, if you want to know the difference in a one-liner, it's basically a data analyst knows all the statistics, Spark programming type stuff, except generally isn't assumed to know the machine learning and deep learning techniques, which are where I think you really, really stand out. And that's what I recommend. Okay, that's the end of that talk. And any questions?
Hello, Greg.
Hey.
We have some questions for you. Clarice asked, as someone who has recently been interested in data analytics, do you recommend for us to take online courses in data analytics first before jumping to data science? Why or why not?
Yeah, so I think that makes perfect sense. So basically, data science, as I kind of said in the very end there, data science is basically data analytics plus machine learning and deep learning techniques. So anything that you're learning about analytics will be directly helpful, and it is kind of confusing if you go to search on Coursera, for example, and you see that IBM has both a data analytics certificate and a data science certificate. Is it a waste of time to look at the analytics one? Definitely not. They'll actually be very similar. Um, so honestly, yeah, do what you want to do, and anything in analytics will be definitely work towards the data science stuff, and is essentially the same thing in many regards anyway. Yeah.
I think the second question you kind of answered this already, but what is the difference between data science and data analytics?
Yeah, just to make that really, really clear. Um, Data science, if you go to look up the definition, is basically, it just tells you like you're good at working with data, and or if you watch the famous, or if you YouTube data, what is data science, you'll get a Joma Tech video saying about how it's about getting value from data, and it doesn't matter about the tools. And I agree with all that. It's incredibly similar to data analytics, except it is generally assumed in just society, and the term of what we've known this to mean is that you are assumed to know deep learning type techniques. If a job says data scientist, it generally assumes that you know, say, the deep learning models like CNN, LSTM, how they're optimized, like through gradient descent and the linear algebra and all of that sort of mathematics stuff. Whereas a data analyst, it's more so SQL, data visualization, which you need for data scientist. It's just really that extra step up.
Okay. And then Jordan asked, would you consider it disadvantages to focus on using an ORM rather than pure SQL, or does it really matter?
Let me Google what ORM is.
Maybe, yeah.
Oh, my Google seems to be talking to me. What is object relational mapping? Is technique that lets you query so sort of, I would assume it means sort of other non-SQL type techniques to get to use databases. And I'll just tell you that SQL is a little bit more common, and it'll stick around for quite a while. But it's true that I said SQL and I didn't talk about the other sort of techniques to manipulate databases, and all of those, yeah, they're useful skills.
Jordan also asked, how much emphasis would you place on OOP versus a functional style of programming? What do you consider advantages to be well versed in OOP?
Yeah, so that's actually a really good question. Is that also the step up from data scientist, from data analyst to data scientist, is you are also kind of assumed to be just a pretty darn good programmer. And a lot of people might think that because it's about data, you don't need to be that good at programming. Yes, actually, I would place a fair amount of emphasis on being genuinely good at programming. Most of the higher end jobs will ask you a sort of, I think I heard it recently, like the lead code hacker rank type style questions. And they might ask you about software engineering principles like object-oriented programming stuff. Yeah.
Okay. And then Barbara asked, is there any particular study certificate you would recommend for a career in NLP?
Certificate for NLP. Yes, I mean this. So I generally recommend Coursera. So NLP right now is mostly rooted still in like deep learning techniques, and that's why I say just become a general data scientist, and you'll learn most of that stuff. So I would recommend working your way up to the entering deep learning course. I believe it is course 5, the last one, where they talk about the techniques for NLP. I would definitely recommend getting that. And I believe there is also, in particular, a natural language processing based course with that actual name on Coursera as well. Yeah.
Okay. And then for our last question, could you please tell us the difference between machine learning engineering and data science too?
It's
Everyone has a lot of questions about that.
Yeah, well, it's because it's really confusing terminology and it's just a pain in the butt. Data science versus machine learning is, in my opinion, there's essentially no difference. Uh, Machine learning engineering definitely implies like actually making a model. Data science implies uh, being able to make models and get all the data, like use SQL and all that stuff to do that. I consider them as really basically the exact same thing.
Okay. Okay. Thank you so much for answering our questions. And
Thank you.
thank you for coming and participating.
Thanks so much.
So next up for our talk is Uro Wirtz from Fujitsu. She's the Deputy Chief Data Officer and will give us a great talk on shaping your own career. Welcome.
Yeah, hello everybody. And yeah, thank you for the invitation. I hope you can see my screen. Everything should be okay. Yeah, so my name is Udo Wirtz, as you said, Deputy Chief Data Officer for Products in Europe at Fujitsu and driving, of course, AI activities at Fujitsu. And the topic today is shaping your own career and being extraordinary or just the mainstream. And I would like to give you some insights from the real business, so to speak, from requirements we see from projects. And therefore, let's start into it. Even if this slide looks a little bit like marketing, the message here is a different one. So when you go ahead and shaping your own career in terms of being a data scientist, as an example, then you should also watch out for companies who are spending money in terms of technologies. So as you can see here, of course, Fujitsu is also doing this, spending a lot of money and creating a lot of patents, number 6 on this planet. The thing is, you get a good playground, you get a good budget, so that you can really train yourself and develop yourself further, and making sure that you have really the right skills in place and having your nose on the market, so to speak. You can see that the companies, of course, from the US are very well known, but a lot of Japanese as well. So nobody knows this. This is a little bit a topic where the Japanese companies are rejecting to do marketing in this respect. But they are really in a good shape, spending a lot of money for research and development. And of course, other countries like Germany, China, Finland, also the Netherlands. But you can see here the majority is definitely Japan. So this is definitely one thing to watch out. Another one is I think the market is good right now, also starting into those type of business. As you can see here, and those numbers are already 2 years ago, and believe me, they are actual than ever. We see a lot of people missing on the market, so they are simply not available. So you see that in the European Union, at least it's more than 500,000 specialists. And you can also see that when you have a look on the graph below, as an example, in the Netherlands, we have more than 70% of the companies have issues to hire the right person, to hire the right staff and skills. And this is a good time now to approach the market. And this will also be the fact over the next years. So, and you see also that there's a huge transformation in the automotive sector, but not only there, also in the financial sector, in other sectors, where now the market is shifting away from the mechanical topic into the IT topic, which means there is a huge demand of having developers in place. And this brings additional pressure on the market. Now, when we talk about the market, what is the market? So on one hand, we have 2/3 of the market about machine learning, deep learning, which is more or less the same thing. So deep learning is a subset of machine learning, capable to learn from unknown data and identify data patterns with technologies like unsupervised learning and things like this. We see a growth in natural language processing, 18%, might be a little bit more meanwhile. Computer vision, which is a huge field. Think about self-driving cars, think about industrial sector, but also machine reasoning. So when it's all about explainable AI. So still a field of research, but could be an interesting topic for you as well. Now, when we talk about entering the market and what's the right skill in terms of software, and I grabbed the most relevant out for you. So as you can see here, we have those big names like Google, Facebook, Uber, but also universities like here's the California Berkeley University. They have created frameworks which are used to create solutions for AI and machine learning. So for Google, TensorFlow, which is the most relevant on the market from my point of view, Keras, which is a high-level API to make development for TensorFlow easier. Then PyTorch, Caffe2 is now integrated into PyTorch. Horwood for multiple device trainings, and Caffe, an older framework. As you can see here from the year when they were published, it may look that, as an example, TensorFlow is still 7 years old, but you have to keep in mind those were one of the first versions, and they have seen a significant improvement over the last years. So I think now they're very matured, and it makes a lot of sense to have a deeper dive into them and making sure you have the right skills with those frameworks. Now, when we have a look on the growth rate, and just to underline what I said, there was a comparison of number of projects at the beginning of the year and end of the year. And as you can see here, the growth of TensorFlow project was significant. It was more than 200% or roughly 200%. And of course, Keras is linear to this because it's related to TensorFlow, but also PyTorch, which was also driven by the integration of Caffe2 into PyTorch. But I think at least having a very good knowledge in TensorFlow and PyTorch makes a lot of sense to bring your career on track in the market. So required skills from a programming point of view. So of course, Python is the most popular and important programming language for AI. So 40%, I take the whole number, is Python, 20% is C, C++, and then others as well. So by myself, I'm a C programmer. I can also program in Python, but it could also be interesting to be focusing or to focus on a specific language. So as an example, when you think about starting a career in the automotive business or industrial sector, where you must have real-time capabilities in place from a language point of view, C++ could make a lot of sense. Python is a little bit harder in this respect. If you would like to go more for a generic approach, Python is a good choice. So also when companies are hiring people, it could be interesting that you have C++ knowledge because there are not that many developers out there having a deep dive knowledge into C++. And this could give you an additional opportunity and also making sure you get a higher salary. At the same point in time, the number of jobs that are offered to the market might be a little bit less in comparison to Python. On the other hand, we are talking about technologies in terms of platforms. So which means we're talking about Linux, we're talking about Docker, and Docker is a placeholder for container services like SUSE Ranger or Red Hat OpenShift and others as well, and Kubernetes. And this brings me to the point of have a look into the connected AI technologies. And this was a survey of 90,000 developers done at stackoverflow.com 2 years ago, but still actual numbers from my point of view. So what you can see here is that if you go in a direction of TensorFlow and PyTorch, Linux is definitely one of the technologies you should consider as well, having a knowledge in it. Of course, you can run those software elements also on Windows machines, but you should keep in mind that this is not the usual way, and it makes a lot of sense also to be here connected. Also, Microsoft Azure is running on Linux technologies as well, by the way. So having knowledge in this respect makes sense. As you can see here with C and C++, this is an additional island, and which means it's very flexible. You can use it in the Microsoft arena as well as in the Linux scenario as well. So in any case, it makes sense to have a look on those connected technologies. Also, one thing you should consider is what is the field of interest you really would like to go forward. So is it images and time series, or is it more in a direction of text analysis or speech? So when you think about having or starting a career in the industrial sector or automotive sector, then images and time series makes a lot of sense. Think about self-driving cars, think about quality assurance and other related technologies that can be done with AI. If you would like to go in the direction of being part in a government organization or insurance company, as an example, text and document analysis could be the right way for you, or speech recognition in different flavors. Now, this said, let me show you one use case where we have connected AI and virtual reality and augmented reality, and which was also shown at the NVIDIA GTC. It's just a few minutes, and just like to give you an overview. What are recommendations of customers on the market? In this example here, and maybe before we start into this, what's the approach here? A company has produced a machine, and the machine has an issue. The machine was delivered to a customer. The customer sits thousands of kilometers away, and the specialist has to give advice to the customer how to fix the problem. And this is exactly what we have done also here, or as a showcase here, how to do this. So what you can see here is a colleague of mine. We have a little application, and the application sits on an augmented reality lens, which is a Microsoft HoloLens. And first of all, my colleague is playing the customer. The customer needs support. In this example, we have a little robot arm, which is now here in my home office. And the robot arm has to learn some new movements, but the customer don't know how to do these movements. And therefore, the customer must meet the technician, and the technician is, as I said, thousands of kilometers away. So first of all, he is now starting a session and is choosing an avatar, which will appear later on in the virtual space. And the avatar will be helping the supporter to see what the customer is doing, and later on also the other way around. You will see this in a minute. So now he has the capability to steer the robot arm, and you can do this by pushing those little hands here on the left side of the menu. And now once the hand is moved over, then we see the virtual device in the hand. And you can now also see the physical device here in the video as well. And when you now have a look to the table, you can see the robot arm, which is under normal conditions a machine at the customer side. Now, first of all, it's important to demonstrate that it's possible to interact virtual and physical devices. And this is what's shown here. And this makes sure that we can really give or synchronize movements from the virtual space to the reality. So the idea is later on that the supporter give a helping hand to the customer to change parts of a machine, demonstrating the customer how to reassemble and assemble the machine, what kind of screws have to be tightened as an example, and other things, more parameters, advice, and etc. Now, once this is done, the technician now has to go into the virtual space, and this is what you can see here. So that's me. So I'm wearing an Oculus Quest, and this is only the starting screen that you can see in the upper left window. So now I have to start the application, which will allow me to meet the colleague in the virtual space. Everything is also powered by AI models, making sure we can track those movements, etc. I also now have to select an avatar, and there are various and different avatars available. Like as you can see here, Jana or Nathan or Lisa, and I think it's also Eric, which is available. Yes, I would like to have hair again, so therefore I choose Jana, and Jana is my avatar. She's doing now all the movements I'm doing. So, and on the upper left window, you see now the factory, and this is Alex, the avatar of Alex. And when I look around, this looks nice. So this is how a typical factory will look like. Now, in front of me is a table, and on the table stands the robot, and this will help me later on to give support to Alex. So first of all, we have to synchronize the movements of the avatars and all the persons, and therefore we are waving our hands, and this is what we are doing here. And the avatar of Alex is not synchronizing, so we have to do this again. And now Alex is also waving the hand, and the avatar is waving, so everything is fine. So all avatars and physical persons are now synchronized. So next step is that we would like to demonstrate movements in the virtual space and bring this to Alex so that he can see how to do the movement in an appropriate way. Therefore, I can choose a menu, and this is what I will do now with the button, which is located right on the table. And once this menu is appearing, I can also now start the movement of the robot. So therefore, I push the button with the little hand that you can see here on the left side. By the way, from a technology point of view, we have also YOLO models in place for movements and identifying object movements. So now you see a red bubble around the robot. And now when I touch the robot is moving in the right direction. So, and this is now what Alex can see through the HoloLens in the augmented reality. So under normal conditions, I'm thousands of kilometers away. I can only see the virtual space, and Alex can only see the avatar. And now we will also have a closer look through the lens of Alex when Alex only sees the avatar. So, which means Jana, which is my avatar. So this is how Alex sees me. So he sees, okay, I'm putting the hands here, and then I'm putting the hands here. And this is how to move the robot in an appropriate way. As I said, this is a simple use case just to demonstrate it's possible. And now Alex can do the movement by his own, and I can control this in the virtual space. And I can tell him, yeah, this was not enough. You have to be more on the downside, and everything is fine. So this is one example. Another example that you can do as a data scientist is, of course, optimizing neural networks. On the left side, you see a single shot detector when you download it from the internet and train it. And on the right side, you can see it when you improve it by adding additional pooling layers and convolution layers and making sure you have a tiny object detection in place, which is needed as an example, on one hand, to identify those objects in an appropriate way, and to steer traffic as an example, or to support self-driving cars, or to make sure that you can control environments, making sure they are safe. So my own career, and this is where I would like to give you some information. I hope they're useful. I have done a different way in starting into my career. I started as an electronics by doing a training in 1988. You see, I'm a little bit older, 53 right now. And then I was working as an IT engineer and doing all of those network stuff. Then I moved over and was a software developer for a lot of years. C development assembler was my topic. And then once the company was closed, we were moving over to our mother company, and I was a technical pre-sales. And one of the last company I was supporting was searching for an CIO, and therefore I moved over to them, and was a CIO for 17 years. After that, I was a founder of Cloud Germany, a cloud service provider. And once the company was sold, I was the head of IT operations of the buyer's company. And from there, I moved over to Fujitsu, and this is where I'm located. I've worked in the Silicon Valley for some time for Fujitsu in Palo Alto and Sunnyvale, doing some projects with companies, and this was definitely an interesting time. So my advice and the golden career rule I have in mind is be visible, do good and talk about it. So if nobody knows what you can do, nobody will take care of you. And please use channels that are really professionally useful for you. And this is what I really would like to emphasize. And let me give you some examples. So one thing is have your own website in place, and also business platforms such as LinkedIn. LinkedIn is very powerful. Definitely, personally, I don't use it that much as it would be or should be. But I have at least my career listed on LinkedIn and Xing, making sure I'm visible to the outside world. Making sure you are also visible in magazines as an example, and writing blogs. And doing this in your own language could also be a specific topic. I'm doing my YouTube channel as an example in German language, because most of the YouTube channels are done in English language, but there are a lot out there in the market. And I was doing some videos with a famous YouTuber, GB Performance, as an example, with self-driving cars, but also giving a lot of basic information, how neural networks work and advices to companies and so on and so forth. And the last advice is really use social networks wisely. Be aware that if you are looking for a new job, the HR guys, first thing is what they are doing is they will look into the internet. What's the person? Do they see pictures from parties, drinks, being drunken, drink and drive, or whatever? It's not a good approach. Please make sure that all the images you are posting, the information you give in the internet is supporting your career. Really, believe me, this can really make a difference. I have seen this at other colleagues. It could be a big hurdle if you have a bad image created in the internet, and then later on you would like to get a great job. And the thing is, the higher the level of the job is you would like to approach, the harder it is, or the more important it is to have a good CV also in this respect from a social media point of view. This said, I think we are in time. Thanks a lot for the invitation, and I'm happy to answer questions. Thank you.
Hi, Yuro. How are you? Thank you for giving us this presentation. We have actually two questions for you. One is both are from Jordan, actually, and he wants to know, I understand that this is a bit tangential, but I'm very curious to know your thoughts on Rust as an alternative to C and C++. I know that Rust adoption has been increasing recently, but do you think it's a viable alternative?
Yeah, I have no experience in Rust, to be honest, from some installations, but I'm not a specialist in this respect. I'm not sure I can really answer this question in an appropriate way. I'm personally interested in Golang. So Go is, from my point of view, an interesting language, also to watch out. But with Rust, I think I cannot answer the question as really to give an information here in this respect.
Okay. And then the other question is, the projects that you demonstrated are incredibly fascinating. I do wonder, especially with the AR VR project you highlighted, how long do you estimate it will take for widespread global adoption of the technology?
So what we see is it's a huge speed up now with this technology. So because on one hand, the companies don't have the right stuff and skills in place, and they must give support over distance. And by myself, in my daily business, I have a bunch of project requests from customers for HR and AR and VR technologies. And for trainings, as an example, or in environments you can't enter easily, think about a problem with a turbine on a ship, as an example, or plane, where you can't travel very easily. You must give remote support. Or machine, you have produced a machine, it was delivered thousands of miles away, and now the machine has an issue. So for that point of view, but also for training videos. So our customers are now doing training videos with this type of technology, so that you can have a first aid, so to speak, how to repair a machine, how to bring the machine back online again, and other things more. And this technology is also related to the decision level because it improves the business. And this is, by the way, generic for all the AI stuff. And this is what you should keep in mind. AI is not the fancy additional thing in the infrastructure of the data center. It's really a technology to bring the original business of a company forward. And therefore, this is a hot topic for the C-level guys, for the decision makers. And therefore, those technologies are moving now faster ahead because those guys have the budget, right? And they're spending it, they're hiring the right people. And so if you're a specialist in AR and VR, it's definitely also a very interesting topic for your career planning.
Thank you. Thank you so much for answering the questions and for your talk as well. It was great hearing you. And now I'm happy to introduce our next speaker, Adora Nodo. Adora works at Microsoft as a software engineer, and she also has a blog called Adora Hack, where she publishes articles on software development, and she'll talk to us about getting started with cloud engineering. So welcome.
Hi, it's really nice to be here. Hi, good morning, afternoon, evening, depending on where you are joining this from. Yeah, I'm excited to do this today. I just need to get my slides up. Yes, so hi everyone. Today I will be talking about getting started with cloud engineering, but before I get right into this properly, I would quickly want to introduce myself. My name is Adora, and I currently work as a software engineer building mixed reality on the cloud at Microsoft. So I basically am part of a team building the engine that building the engine that mixed reality would run on, sort of. I'm also an author. I published a book on cloud engineering recently. I am the VP of VR AR Association Nigeria. There's a global community called the VR AR Association. So it's like, for VR enthusiasts, AR enthusiasts, VR customers, AR developers, everybody from enthusiasts to customers to developers to consumers, people that are interested in the technology and the business. So there's a Nigerian chapter, and I currently lead that. I'm also a digital creator, so I post videos, courses, Instagram content, teaching people about tech, and sharing what my life as a developer looks like as well. This is what my book looks like. Like I said, I am the author of a new cloud engineering book, and this book is particularly special to me because it is helping people. It's a foundational book helping people start their cloud engineering careers, and I've gotten really great feedback about the book in recent times. So just wanted to put that there as well. And because this is like a cloud engineering talk, it made sense to talk about the cloud engineering book for a little bit as well. So a brief overview of what cloud engineering is. Before we get to what cloud engineering is, let's sort of talk about cloud computing and what it is. Cloud computing is basically, first of all, let's even go a step backward and talk about what the cloud is. And a lot of people would say, oh, the cloud is somebody else's computer that offers you somebody else's computer. And then now, so cloud computing is like, okay, leveraging somebody else's computer, taking the load off your computer and leveraging somebody else's computer to do work, basically. So in the same regard, it's like computing over the internet. And when multiple people are able to connect over a network to the cloud, they are able to, share things. And then there's faster innovation, flexible resources, and economies of scale. And cloud engineering is not DevOps. Just want to say this thing real quick because I've been in a lot of conversations and situations where people are talking about cloud engineering and it's like, okay, I'm looking for a cloud engineer, DevOps slash SRE. And there's a lot more than DevOps and SRE when it comes to things of the cloud. These are very, very, very important roles. And if I'm being honest, because the cloud exists, these roles exist. And the cloud wouldn't we wouldn't have the kind of cloud that we have today, and we wouldn't be doing computing with the ease that we do it today if these roles did not exist. So these roles are very important, right? But I guess what I'm saying is that there's a lot more to the cloud or to cloud engineering careers than just the these two roles. And cloud engineering is like a field of engineering that focuses on cloud services. So it's an umbrella term. So whether you are a software architect, software engineer, infrastructure engineer, and whatever it is, you so far as you are working on the cloud, you are doing so far as you are doing engineering on the cloud, you are in that way a cloud engineer. And these are some of the cloud engineering fields listed here. So software architects focus on defining the structure, the architecture of different cloud systems that you want to build and all of that. Software engineers focus on building these cloud services. DevOps people make it easy for us to have that whole agile process. They make it easy for deployments to happen. They make it easy for us to have that flow when it comes to writing code and then able to deploy your code and then maintaining a healthy system from start to finish. That's DevOps. And then security is very important because we are on the internet, right? And your data is on the internet, your customers' data is on the internet, it's on the cloud somewhere. Meaning that if you don't put the right measures in place, people that want to get access to your information or your customers' information can do that. So cloud security is another important role that exists in the space of cloud engineering, and so much more if we're being honest. And before I go any further, I kind of also want to talk about why cloud computing is important. The first thing is that, as we can see here, it is in high demand because I went online and I was looking for cloud engineering jobs, and then I just randomly searched and I found 182,912 opportunities for cloud engineering jobs. And this is obviously not only across the world. I'm talking maybe Europe and North America. What happens in other parts of the world that still, builds technology and are still hiring engineers? There are lots of, and this isn't only even the only sites that jobs get listed. So as we can see here, 182,912 is a lot, right? And this is the number of cloud engineering jobs that I saw at the time when I did this search, meaning that there are many opportunities for cloud engineers today compared to the amount of cloud engineers that exist, meaning that there's a high demand for skilled cloud engineers to come into this field and take these roles today. So that's one reason why, if you were not thinking about it before, it's something worth considering. Another thing is high earnings compared to other things. So as a cloud engineer, you manage and monitor cloud computing system. Your job duties include creating, testing, and implementing cloud technologies based on the demands of your business. Many cloud engineers are involved in other aspects of information technology as well. But you would mostly be doing software engineering, infrastructure engineering, SRE, cloud security, software architecture, and all these things. Sometimes you do support as well. But it depends on the particular, at the end of the day, it's not like somebody's going to tell you you are a cloud engineer and you have to do everything that I just mentioned. So depending on the demands of your business, you might just be building for the cloud, or you might be doing some DevOps, or you might be a site reliability engineer, or you might be focused on cloud security. And what this means is that you have a chance to earn this on, entry level. Now, I'm not even talking senior cloud engineers or whatever. I'm talking like baseline. I did this research and I found that, the average salary of an entry level cloud engineer is about 128,837 USD per year. So why exactly wouldn't you want to end that if you have the opportunity to? Also, the next thing I would say is there are job prospects in multiple industries. So everybody is trying to automate their business today. I know that there are a lot of tech startups coming up doing amazing things for tech people and for other people beyond tech. But the truth is, people outside of the tech ecosystem are also trying to automate their business. We see people, entrepreneurs trying to do the same. We see people in medicine trying to do the same, law, and all these other different sectors. What this means is that as a cloud engineer, you would be able to get jobs that would allow you do, build cloud services, maintain the cloud services for these people across multiple industries. So you don't have to, okay, focus on a traditional tech company that builds services for people. You can focus on, the fashion industry, maybe a company that you like that runs an online fashion business, and a lot of the computing is on the cloud and e-commerce platform, and you're focusing on that. Or you can focus on maybe a law firm that is using technology for something. Or you can focus on a school. Like, you can, if you care so much about education and you want to work in academia, even if you don't want to work as a professor, you can also focus on rendering your services in these varying industries. And that's one thing that I find really interesting about this as well, and how the adoption of the internet is driving this and making it happen in such a way that nowadays people don't even realize that they are cloud engineers when they are. So they just think, oh, I'm a backend person, or I'm a web engineer. But actually, if you think about it, where exactly is your code being deployed to? All the things, all the code that you write, all the things that you build, where is it going? Who are you building it for? A lot of things we do on the cloud, and now it's like everyone has to start thinking about the fact that even when you see every single technology that we're building nowadays, it's like the cloud is the foundational tool for building that technology. When we think about AR, VR, when we think about mixed reality, I mean, I was just talking about it now that I am, building mixed reality on the cloud so that other people can plug into this engine or service and build out their own mixed reality experience. So the cloud is like the foundational technology for all these other cool things that we want to build. So we're building on top of it, which means that there are a bunch of important skills that are necessary to have when we're thinking about building for the cloud and cloud engineering. One of them is that you need to know cloud service providers. This is a no-brainer. If you are going to be building for the cloud, if you're going to be building cloud services, maintaining cloud services, securing cloud services, whatever you're going to be doing in the context of cloud services, you need to understand cloud services. These are very popular cloud providers that I've put here right now: Microsoft Azure, Google Cloud, AWS, and DigitalOcean. If you don't know any of them, feel free to check them out and learn from there. There are a bunch of Udemy courses. There's some Udacity courses as well that you can take that would help you understand, these cloud service providers. And there are even some certifications as well that you can get that, once you are cloud certified, can help you become, better as you forge along in your cloud journey. Programming is also important because even if no matter what you do, whether as a software engineer, first of all, let's talk about query languages. As a software engineer, if you work on the back end, you're going to be you might find yourself in scenarios where you query your database sometimes. If you are a support person, when you see errors in, a particular service, you might need to go and query logs as well. So because of that, having basic query language syntax, having the knowledge of that would help you do well as, somebody working on the cloud. If you're in security as well and you are trying to audit something, you might need to go look at some logs when you're trying to figure out maybe what's the root cause of a particular problem. Maybe something got leaked, a secret somewhere, and you might want to go check logs to see where the traffic came from and who logged a password they were not supposed to log or something like that. So understanding query languages so that you can navigate this properly is one important things. Version control as well, right? Because you're still going to be writing code, so it's nice to know Git. There are many languages for the cloud: JavaScript, C#, Golang, and a lot more. So if you are trying to get into cloud engineering and you want to build for the cloud, so you want to build cloud services, you want to write code that would, power these cloud services that would help you, build on the cloud. For example, Firebase is a cloud service, right? Let's think about one. Azure Cosmos DB is a cloud service, right? So these things exist on the cloud and they are serving multiple people, and they were written with code. I know that, yes, you write code to call them, but they were also written with code. So these are examples of cloud services. So if you want to build these kinds of things, and that's the area of cloud engineering you want to focus on, then sure, you can, learn one of all these languages: JavaScript, C#, Golang, or all of them if you're feeling up to it. Knowledge of APIs and web services, because like I said, you find yourself using a bunch of different other services as well. You deal with WebSockets a lot. You call APIs, so you need to learn how to make API requests and decode API responses. Security architectural patterns as well would help you write code that is security compliant and then build resilient services as well. Learning disaster recovery, threat modeling, these are important tools if you're someone that's these are important things to know if you're someone that is trying to learn about cloud security. Operating systems as well, and I put Linux there because I think that's like one that is very important. Even if after learning Linux you want to decide that, okay, you want to learn how to use other ones, like, okay, you want to learn a bunch of Windows terminal commands, you want to learn a bunch of all these things, then that's right. And I'm saying it because a lot of times as a cloud engineer, if you're trying to, deploy an application to a virtual machine, you might always be using a Linux virtual machine. You might always be using a Linux VM. Doesn't mean that once in a while you wouldn't use other VMs, but sometimes you would use a Linux VM. So it's important to learn how to use Linux, how to write Linux commands, and work in that shell before you decide to take it up. Infrastructure engineering, if you're trying to be someone that is working on the cloud infrastructure / DevOps side. So you might need to learn a lot about, containerization and virtualization. You might need to learn about Docker. You might need to learn about Kubernetes. You might need to learn about building cloud native applications. You need to learn about infrastructure as code, because now everyone is moving beyond manually deploying, infrastructure for their service. So like, I want to create and building an app that uses the serverless architecture, and then I'm opening the Azure portal to create an Azure function app there. I don't think many people do that anymore. So what happens is that people use infrastructure as code to define the kinds of infrastructure that they need, and then these are some infrastructure as code tools that you can use: Terraform, Pulumi, Ansible, Azure Bicep, CloudFormation, and a lot more. PowerShell terminal as well, if you're trying to get into that. This is what Pulumi sort of looks like, and it's something that I would totally recommend, because if you're someone that already writes code, let's say you write Python, or you write C#, or you write JavaScript, and you're trying to get into infrastructure as code, but you don't really have the time to learn a new language or to learn HCL and use Terraform. You don't really have the time to learn HCL and use Terraform. You don't really have the time to start understanding how Azure Resource Manager works and how you can use ARM to define your resources. You can just plug into this Pulumi website, and you'll be able to use normal programming languages like JavaScript and Python to define your application's infrastructure. So the next section now, how do you get started with cloud engineering? The first thing I would say again is buy my book. I've gotten a lot of feedback about this book, providing people clarity and helping them start their cloud engineering journey. So if that's something that you're interested in, then I'll advise you to go for it. There are other ways to get started. You can get the AWS training from the Amazon website. This is a slide that I would advise you to take a screenshot of. You can take the cloud engineering certification from Google Cloud, and then you can go to the Microsoft documentation and learn how to use Azure. Another thing that is interesting to me is that you have the entire internet to yourself to learn about cloud. There are people writing a lot of articles, doing videos, Udemy courses, many places to start, a bunch of certifications that exist as well on Udemy, on Udacity. I would totally recommend them. Go check them out and then start your journey. Thank you so much for watching. I know that I have some minutes left, so if there are any questions, I guess I would want to answer them now.
Hello. We have a few questions for you. Emmanuel asked, for someone starting out in cloud engineering, what is the recommended start, Google Cloud Platform or Amazon Web Services?
At the end of the day, the recommended start is the fundamentals of cloud engineering. Unfortunately, it is not a platform, because Google Cloud Platform, Amazon Web Services, Microsoft Azure, DigitalOcean, Oracle's own version of their cloud provider, they all do the same thing. They are just run by different companies. So except you're targeting a particular company that uses a particular technology, so you want to get a certification. Like maybe if I want to work at Twitter, for example, I don't know how true this is, but I've heard in the past that Twitter used AWS. I can now focus on learning AWS so that I can, apply for a role at Twitter and say that I have some level of AWS proficiency, and I can say that in my interview. But it doesn't mean that I need AWS to kickstart my cloud engineering career, because if I was applying to a different company that uses Microsoft Azure primarily, I would have learned that. So I guess that for someone starting out in cloud engineering, the first thing you need to do is actually get and learn the fundamentals of cloud engineering, not necessarily the different platforms, because they all do the same thing. They're just run by different people in different companies.
Okay. And then Jordan asked, would you say that cloud engineering is a subset or superset of the DevOps toolkit? Or am I thinking about this wrong? What is the difference between DevOps and cloud engineering?
I kind of said that at the beginning of this talk, so it's fine. DevOps is a subset of cloud engineering. Cloud engineering is the umbrella term for DevOps, for any kind of engineering that you do on the cloud, basically. So as a DevOps engineer, you are a cloud engineer. As a cloud security person, you call yourself a cloud engineer as well. As a software engineer building cloud services, you are a cloud engineer. So DevOps is the role that, helps you define processes that allow people build, manage, and deploy scalable applications. So you're thinking about, okay, is the pipeline working? Is it broken? How do I strengthen this thing? You get what I mean? But DevOps is not cloud engineering, because cloud engineering is DevOps plus every other kind of engineering you do on the cloud, if that makes sense.
Yeah, that makes sense. Thank you so much for answering our questions. And thank you for talking to us. It was a great talk. And so next up, I'll present our next speaker. And it's Joab Kochler. He'll be taking the stage next. He's a data engineer at DataWorks and will present a very interesting case study on using an Xbox Connect. You're welcome.
Hi, Isabel. Oh, sorry, Isabel. Isadora, sorry.
I think I also said your name wrong. So.
Yeah, you're not the only one. It's a very Dutch name, so it doesn't matter. No, thanks for the introduction. Thanks for having me.
Thank you.
All right, let me prepare my screen. Yes, because I had something here. I have. Right. You could all see my screen. All right. I'm talking about being safe on a bike using an Xbox Connect. This is about that story. It's not really a Connect, but we'll get to that part. First, I'm going to give you a little bit of background. If anybody knows the Netherlands, you know that we have DJs. We have drugs to endure those DJs. It's part of Amsterdam, and we have a lot of bikes. This will cause a lot of news if you know the latest news regarding the bikes. These are all Dutch bike headlines. If you don't understand Dutch, and I won't force you to read those and translate those, but this is actually the rough translation of these newspapers. It is just boomer having problems using electronic device. This is something we know what happens, but this is something because of the boost of people buying electric bikes, not knowing how to handle that, and also being a danger on the road. So we thought, let's help those people on the bike. So our goal as a team, we should say, all right, we're going to recognize dangers on the road before the cyclists and assist them during the ride. We're not trying to create an autopilot for bikes, a little bit, but we don't want to be the next Musk. We're just trying to create something that is useful for the people on the bikes. But first, what is a we? In our team, we're a couple of data engineers and a couple of data scientists, and it's a balanced way of doing these kinds of projects. For us, this means that we have our own responsibility and do our own thing. We help each other, but we do have our own specific specialty that we're proud of that we're doing. So we might learn from each other, but we still have our own thing to do. So let's get back to the part. What do we need? We need something that is or has a camera. It can be powered by USB, because USB is very standard. We need something that we can program, preferably on the device itself, so that we don't have to carry a $2,000 MacBook with it. And we need something small. So we thought first, all right, this is a Connect. Let's paint the picture here. What does it look like if you have someone on a bike? Let's say this person, don't know this person, but let's say we have this person on a bike. How does this look like? Now, we put the Connect on the bike in front of it because we need to know what's happening in front of it. We need to power it, and we need to give it some computing power, and we also need to give the brain, because some people on bikes don't have a brain. This kinda is what we're looking at. So there are people who made this thing actually in a box for a prototype. So here you can see the prototype. This is actually with a 4K camera with a stereo. I think it is a stereo camera on beneath it. And here you'll see that you have the Raspberry Pi attached to it, all of the cables attached to it with a little bit of power and a computing stick. Now this actually works. Because in 2010 we had the Connect. This is the newest version of Connect. But the problem was with this version, we have a low resolution camera on it. We have assisted execution. You still need the Xbox with this. And it's quite large. So this is something we don't want to put on our bikes. Fortunately, in 2021, there was a revelation, because there was this part, a camera with an attached stereo camera in. And it has not only is it faster, it has on-edge execution, and it's very small. This combines everything that we wanted inside of this particular device. So this is really cool for us to use. So why not do it separate? As I can show you a box again, but that is all separate. So why not do that? Gives you more modularity. Well, the thing is, if you buy a 4K camera nowadays, certainly if you can get one, that is one part of the problem. You want to have stereo depth on your camera, and you want to have an AI processor. It will cost you around 500 euros, $500 in this case. And the beauty of the thing that I've just shown you, the EOD, is only $200. So this is something we wanted to get our hands on. So how did we get one? Yeah, we got lucky. we got into this OpenCV AI competition. For the people who don't know what OpenCV is, go to this website. It explains you a lot. The CV in OpenCV is actually computer vision, for people who don't know. But as I was saying, we got in that competition with a lot of ideas. BikeWorks, as we call it, the assisted bike learning, that was one of the ideas which we all thought this is good to go with. We also got a lot of other ideas, like a sports tracking, incident recognition at home, sports audience that you still can get in your get with your friends in a VR room and watch sports together. We also had one that is for convincing our managers. But these were all the ideas we got, and we chose the BikeWorks one because we thought, all right, this is the one that has the most potential of it. So we got our ID, we got our project, and now we got the hardware. But with only a camera we got, that's not the whole complete picture. We still need to have some more of it. So now we got the camera, and we also need to fill in those other parts. I'm going to talk about a little about the camera because I forgot about the part that I wanted to show you about the platform that is running on the camera. It is open source, and you can look at it. It's called Depth AI. Depth AI is an embedded performance spatial AI CV, that stands for computer vision, a platform composed of open source hardware, firmware, software ecosystem that provides turnkey embedded spatial AI CV, hardware acceleration, computer vision. Yes, I'm reading this from a card because this is a long sentence to remember. The only thing you have to know is that Depth AI provides you a way of programming your device easily and open source, so you can share it with other people and also learn from other people's successes, but also learn from other people's mistakes, because you don't want to do the same thing and expecting the different result. So these are the things what is available in this particular device for us. So what is available for us and what do we need from it? So first of all, we need stereo depth. Why we need stereo depth? I'm going to show you that, because we're going to need stereo depth to see what is how far some things are in front of it. How do we do that? I'm going to show you next. But we also need a 3D object localization. You can do object localization, but not in 3D, and that's why you need stereo depth. We're going to need object tracking, because we're going to know if something is moving and something is standing still. That is very important when you're also in a moving vehicle. And we need on-device Python scripting. Why is this important? We want to have the device so small as possible. So we still need to have everything as enclosed as we want it to have. Like I said before, we don't want to have more parts needed, and we don't want to have to carry a laptop connected to the bike every time we get onto a bike. So first step, what we are going to do will be the object detection. Now this is good. This is very cool because the camera has this model which has it in place. I'm going to check if I'm going to show you I'm going to show you the list after this part, because what you're seeing here, this is object detection is the technical term for finding the bounding box of an object. So here you see three objects that is recognized. It recognized the bicycle, it recognized the truck, and it recognized the dog. So what you're getting back from the camera is the space in which in the picture the certain object is projected, so that you know where the object is in relative to your camera. This isn't really foolproof. It is pretty good, but you still have to be aware that sometimes some errors can occur. To give some insight in what kind of objects that are available to us to recognize, these are the complete list that you wanted to have. For us, these are the things that are interesting for a bike to know if it's important to see what you're doing. Maybe a horse if you're in the outback, or in the outback, maybe an elephant, bear, or zebra. There are a lot of things that could happen when you're on a bike. These are things we'll get back. So the next step, you know where the object detection is. You want to know what the object location is. So that is what you're doing with the depth camera. To give some insight, we tried it out on a Raspberry Pi. And this is the stereo depth pipeline, is what you call it, on the OD, so on the camera. So here, to get some heads up, we're getting into the camera. You're saying actually from the host of Raspberry, you're saying, all right, give me the input from the both of the cameras, so the left and the right, projected on a stereo depth map. Give me the rectified left, give me the rectified right, and compare that, and there you have your disparity. But what is disparity? This is a schematic representation of disparity. For example, if you look at X in this picture, you have a left camera and a right camera, and that X has a certain distance from the left camera and a certain distance from the right camera. And from I'm not a data scientist, so I understand what is happening, but I can't explain it very depth in. So you have to believe me when I'm saying is that from the point of what you're seeing is that the comparison from where your left view and the right view is, you know what the distance from this is in between. So when you're looking at a certain point in view of both, you know what you're looking at because you know what X is, and for the camera left and right, you know what the depth is because you know how far the cameras are apart from each other. This translates to a disparity result. So in the left, you'll see the disparity result from a stereo depth camera. On the right, you'll see the color. You see the same disparity map, but with a color. So here you see what is happening if you have an object in view, and you see what is close and what is not so close. So the more red it gives, the more in the left picture, the more white it gives. The clearer it is for you to know, all right, this is in front of me. The blacker it is, the farther away it is from me. If you map it with a color on the right side, you'll see that the redder the object in the camera view is, the more problems it will give you in the front view. So now we have the camera set up, and I already told you we're going to use a Raspberry Pi, but the reason is, why are we going to use a Raspberry Pi? These are chosen on highly scientific reasons. We made a lot of choices in this regard. We said, all right, you have to have it laid around. We found it in my dresser, and we haven't used it in a while, and it's small and cheap. So this results. These are all bullshit reasons, I know this, but this is what we're looking at. We are looking at something small, and we can program it, and it's relatively easy to use. So what it actually does is, here you see in this picture, this was one of our training camps. That sounds very awful. This is one of our fun camps, and we had to program the device to see, to combine it with some lights, with a Raspberry Pi, and to see if it recognizes a bottle. Here you can see in the picture, I don't think you have sounds, but here you see in the picture that it recognizes the bottle. It recognizes as a model, and it sees in front of the camera if it's in front of it, if it's left, or if it's right. Now this is really cool to see because it does everything that we need it to be. The only thing we're missing is the depth, but that is what we're coming at. To give some insight in that, we don't only recognize bottles. For in this case, bottles. You don't want to have a bottle in your face on the bike, but we also recognize what the depth was, what the depth needed to. Sorry, what we needed to see for the depth, what it was. So here you see a video in what we have a bounding box, and if it's in the bounding box, then we'll recognize, all right, it's a collision alert. So if you come in close in the bounding box, then you know that you're gonna have a collision. All right, this was really cool because this was something that we were expecting us to do, but we were very glad we got it working on time, and we got it working on a testbed setup. But the problem is we didn't have it ready on a bike. So that will be one of our further steps because we didn't want the project to die down. So now our next steps, like I told you, does work. Yes, it does work, but it only works with bottles. So we wanted to work with newer models. So we're gonna have to train this thing to be recognizable in any space when you're on a bike. So does it cost a lot? It doesn't cost a lot yet because if you can have a camera for, like I said, $200, but yeah, we need to make it smaller and cheaper, because we're all going to put it on a bike that is 2,000 euros, an electric bike. So we need to make it smaller and cheaper. So everybody who has a bike, an electric bike preferably, can use it. Does this project have a future? Yes, and we're working on a release this year. We're gonna try to come together with the whole group to get a working project on a working bike. So we don't have an electric bike ourselves, so we're probably gonna borrow them from either my mom or our manager, because he has an electric bike, and we're not gonna try to trash it, but no promises. So how does it look like on the end? Like I said, we don't want to have that on the end. We want to have something smaller. So this is a mount for a GoPro on a bike. So this is something we actually want to have. So when I say small, think of this small. This is the smallest thing we're gonna have. This is actually the end of my presentation. I don't know if you have any questions related to this. Let me stop my screen. Yes.
Hi. Yes, so there is a question for you.
Okay, cool.
In the context of your end-to-end project, what are the responsibilities of a data engineer versus a data scientist, and how are they delimited? Is there a clear separation between the roles, or there is some overlap?
This is a very funny question to me. I like the question. Thanks for asking. This is something we deal with on a daily basis, because if you look at the questions are being asked by companies, what they want from a data engineer or from a data scientist, that kind of overlaps each other. For example, if you're looking at a specific if you're looking for a data scientist. From a company perspective, and you don't have anything lying around, like you have data, but you don't have any pipelines, you don't have any cloud engineering, you don't have anything ready to get on production, then you're not actually looking for a data scientist. You're looking for a data engineer to make this happening. Okay. So this is something, like I said, this is something we're encountering every day. I have people working at DataWorks who are a data scientist, but because of the responsibility and what they're doing now, they're actually doing data engineering work, because they want to have a complete picture of what is happening in the company and what they need to do now. So good question.
Good. Thank you so much for answering the question, and also for your talk and the case study. It was very interesting.
Yeah.
And for our last speaker, but definitely not least, is Marine Marcus. He is a data scientist and works as a consultant at Capgemini. He will be talking to us about how a social scientist makes a difference in our data-dominated world. And we're excited to hear you talk. Hello, welcome.
Evening, everyone. Marijn Marcus here. Thanks for having me. I'm last in line. I'm here to I'm sharing my screen. Let's see if I can share my screen. It's working. Great. I'm here to bother you a little bit about data science, about social science, about data in general, and everything between. Please bear with me. First of all, hi, I'm Marijn. I'm AI lead and managing data scientist. They call it Pokemon names at Capgemini these days. But back in the day, I studied sociology, criminology, and a lot of statistics, which was, no cat, not right now, which was distinctly not as sexy as data science and AI. But it was very real to me, because I learned boring stuff. I learned math. I learned a lot about regression, decision trees. I started out with SPSS and R and Python. And then in 2014, I realized that the stuff I learned in my education could actually help save people's lives. Because Ebola happened. If anyone remembers Ebola, the last worldwide pandemic we had, I was working for NGOs as an intern back then. That's visuals of the models I built about the spread of Ebola through West Africa back then. And we used that stuff on the Dutch national news to raise money to send emergency aid to West Africa. And that was the time I learned that the bullshit I did, pardon my English, with data wasn't just good for papers and for grades, but could actually help people's lives, because we raised 50.6 million euros. And that's actually all I wanted to do in life. From there, I started modeling the crime in my hometown of Rotterdam, to predict how many people get stabbed in which part of the town. I'm in the upper right, by the way. And then Capgemini said, man, that's cool, that's data science. And I said, oh yeah, sure, because I needed a job. That's how I ended up in data science as a social scientist. Any questions? Oh wait, I still have like 50 minutes left. So the joke is, the stuff I started studying and the stuff many of you as students studied, is incredibly applicable everywhere, from crime to pandemics to modeling what the yield will be of farmers in Kenya. More on that later. And sometimes I talk about it on big stages. That's me. What I learned is that what we call AI nowadays, we used to call it data science. Before that, it was big data, or just data persons. Before that, it was just statistics. And before that, we were just called nerds. And God knows what we'll call it in 5 or 10 years. But I'm pretty sure we'll still have jobs, because there'll still be data and a lot of statistics to do. I just can't tell you what Pokemon name you'll use. And I also learned that the theory we all had back in class, back at university or whatever, is a lot like the stuff you do nowadays, just a hell of a lot more complicated, because you have no good data, you have no simple models, you have a production environment to deal with, you have a ton of legacy systems, you have no proper cloud training or whatever. But the theory and the mechanisms are the same. And for all the students there in the audience, I cannot stress this enough, because the biggest thrill you will ever get in your work is when you found out that the stuff that you know is actually worth something outside of academics. To me, that was the biggest thrill ever. And I'm not even any good at Mario, you know? Now, I hear the word data science being thrown around a lot on LinkedIn in this event over the past few hours. And there's 500 definitions of it, but let me just give you the simplest one. It's solving data problems using scientific methods. That's how I explain it to my mom. And that's what we do. We apply scientific methods to solve data problems for organizations. And well, let's look at the field right now. What's going on in the world? I believe Amazon hit the jackpot by recruiting people using an AI that then only recruited white males, right? And then they said the AI is evil, let's get rid of that. They went back to human recruiting, even though the AI was trained on human recruiting. They were already recruiting the white males and such. It just wasn't explicit because it wasn't captured in data. We were giving state citizenships rights to chatbots for some reason. Apple Pay, does anyone remember Apple Pay, credit card pay? It was a gender neutral algorithm that gave you credit scoring back in the day, credit scoring on how much money you get on credit paying with an Apple iPhone. And it turned out that in practice, it only gave women about half the credit. Why? Because the model did not see gender, it did not see ethnicity. It was very much politically correct, but it just saw people who were around 30, and this one has this credit score, this one has a gap in the CV of 2 years, and also studied marketing, so this one's getting a less credit score. And the data scientists couldn't even check for bias and discrimination in their data set, because the data privacy officer said, oh, no, you can't have that data. And this is a huge thing in our current data field, that every organization, or the vast majority of them that I saw, is producing biased algorithms at scale because data privacy officers tell them, no, you can't use that data. And then afterwards, people come knocking and ask, is your model biased? And you say, I have no freaking clue, because I couldn't get the data to check on it. We have countries like China using data in a ton of different ways to check on their population, and we say it's evil. Simultaneously, our Western governments can't even automate paper processes, so I'm just asking who's really crazy over here. And we have the European Union entering huge legislation on AI. Now, a question to you in the audience. Who of you have fitted a regression algorithm? Because if you have, you are an AI expert according to the European Union. who entered all that legislation but didn't even bother to say what they meant by algorithms and AI. Anything using statistics, they said. Meaning anyone who can use statistics is now an AI expert. Congrats. Simultaneously, we rely on all this tech to figure out who has cancer. And just to give you a tiny bit of the future right now, eye implants. People who got eye implants over the last 15 years, their software, their implants are now no longer being updated because the company went bankrupt. And we have a ton of legislation worldwide about if your phone breaks, if your TV breaks, if your laptop breaks. But this is future noise that we're getting today. What if your cybernetic implants in your brain that Elon Musk wants us to put in our brains, what if that goes out of service, can't receive updates anymore, and if they have any damage to their electrical eyes right now, it can't be repaired because the Silicon Valley corp that ran the whole thing went bankrupt. I'm just very curious to see how this will evolve in the future. But enough about the future. We need to worry about bias inside algorithms as well as outside algorithms. That's the main thing I learned in my work over the last 5 years. And that's the point where I realized that, damn, the stuff I learned in education, in my studies, is actually worth something. I studied this, damn it. I studied gender pay gaps. I studied using math, using statistics, using everything from regression to XGBoost to model distributions and biases. Hell, let's be honest. The entire market currently is screaming about bias in algorithms, but these very same algorithms were developed initially to model bias. Regression, random forest, XGBoost was all developed in the 80s, vast majority in the 80s, to capture effects, cause and effects, to measure it. Meaning we're doing very backwards stuff when we're talking about the dangers of bias in algorithms. Now, I like to build stuff at home like this, like my coffee machine.
Get me coffee.
Here you see me screaming, computer, get me coffee. Which voice activates my coffee machine to get me coffee and get my cat coffee. Yeah, you get lonely during lockdown, you start building stuff like this. My mom says this is AI. You may not think this is AI, but to her it is, and to many, many clients out there in the field that you will work with, this is AI. To me, it's a controller soldered to the power button of my coffee machine with a Wi-Fi node enabled Node MCU, a Raspberry Pi connected to my Alexa, and with a Zigbee plug so I can get data on when there's a power spike, when I'm getting coffee, so I can use a time series model to model my own addiction. You have many modern applications of AI data science, everything from modeling who gets a burnout to who's doing fraudulent driving behavior, to forecasting how many refugees enter or leave the country using hamburger prices, I shit you not, to automatically reading documents, to modeling fish, a friend of mine does that, to chatbots. We all hate chatbots, but they're a real cost saver for call centers, you know? And the vast majority of these projects I actually participated in as a data scientist, and which sounded really scary, but when I was in there, it turned out it wasn't all that scary because it was stuff I knew. It was stuff I had done before. For example, I quit is a very real issue for a lot of organizations. Attrition, people leaving the company. But what if I told you it was very easily predictable who's unhappy, who's about to get a burnout, and who's going to leave the company based on standard HR data like what is their time of service, when was their last pay boost, and when did they last get a promotion? And then I'm like, wait, I studied this. And now we're implementing this at large organizations to explain why people are leaving, why they are dissatisfied, so HR can actually do something about it. And we get a lot of questions, ethical questions these days about, is this allowed? Well, if I can accurately predict the burnouts, in a few years, I'm pretty sure we'll be asking the question, are we allowed not to? Because if you have the data to do this, care for the well-being of your employee, Are you allowed to say, la, 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 no, I don't want to look at this? That's the future we're heading for. Same goes for pay gaps, which to this day is a thing. And every damn company has the data to check it. And still we have huge differences persisting between males, females, different ethnicities, people, men who like men, God knows what, for reasons that have nothing to do with the organization and everything with discrimination. And again, I'm like, wait, I studied for this. Explainability of algorithms is a huge factor nowadays, because if you can't explain why it's working, no matter the accuracy, business won't believe it. People can't use it. This even goes for the NGO work I do as a side hustle for farmers in Kenya and India to predict what their yield will be end of season using satellite imagery to find out the soil quality in that area, but also to predict find the plot sizes of their patches, because every damn farmer in our data set brags about how big their plots are. It's apparently a men thing. But if you want to predict the yield for a smallholder farmer end of season, you need to know the accurate number of their plot size in hectares, not how much they brag about it. So we use machine learning for that. And again, I'm like, wait, hell, I studied this. What the heck is happening? And I wish to you, many of you students, to feel that same joy when you go out in the field and find out that you actually know something that's worth something you can use to help people with it. 40,000 Kenyan farmers have used this at some point. Because at the end of the day, we are solving puzzles as data scientists, and data is our tool. And the same goes for bias. Like, I was predicting who's going to leave. I was predicting burnouts. Turned out the biggest predictor in my model was who's the manager, because you don't leave your company, you leave your boss. So I presented my findings to management saying, hey, everyone's leaving because of some managers. Those managers were in the crowd. I got laughed off stage at that point in time because I wasn't nice about it, basically. You are faced with tough choices in this field because you often get to be the messenger that gets shot, because a lot of problems in a lot of organizations are kept below the surface until somebody looks at the data. Similarly, I analyzed a lot of gender pay gaps for a lot of different organizations. I can either explain to HR how to model that gender pay gap and how they've been making errors there and how they did the math all wrong, or I can choose not to mansplain, because damn it, I'm explaining it to like 5 women and I'm the mansplainer. But the thing is, as the data scientist, you need to be that guy that addresses the tough issues, that addresses those topics, because sooner or later somebody will. And that is part of your job too. And we get so much noise on LinkedIn about, oh, not 80-90% of all data science projects fail. And they say it's because they don't enter production or external factors or legacy or data quality, and all of those are true. But a big unmentioned reason is that often those data science projects find stuff that management, that business, that the organization does not want to acknowledge. Like they're losing money because of their own mistakes. They're losing people, even. And we have a few major Dutch examples of that, but internationally it's all the same. Everyone has skeletons in their closet. And as data scientists, it's our job to pick the right method for the job. Everything from simple rule-based models to neural nets. And then the data privacy officer enters and I go like, I need all the gender data you have, all the ethnicity data you have, and ideally I'd like to know their sexual orientation too. Which is a mess because everyone already hired a data privacy officer just to tell no. The thing is, you need to better sweat now than sweat later, especially with topics like these, especially with sensitive topics like these, because you can't be the one who puts a model like this into production and then they ask you, well, how do you know it's not sexist? And I'm like, I don't know. You didn't give me the data to check. This happens in most organizations right now. And that's where we can make a difference. It's all about data in the end. There are no unbiased algorithms out there. All the EU legislation demanding unbiased algorithms, you can throw it away. It's just, it doesn't exist. Just like there are no unbiased humans either. And you should acknowledge it and allow for it and control for it. Because help me, data is a tool to uncover bias. These models were developed to find it, not to cause it. And man and machine in collaboration are safer than only a machine or only a man, because 4,000, 5,000 years of history taught me not to just trust man. And otherwise, you're just a fool with a tool. Thank you, Mr. I think I'm nearing the end of my talk. Let's be honest, most of the organizations want the predictive part. How do I sell more beer? They can only report how much beer they sold in the past, but the steps in between about why did they sell beer in the past? Was it the weather? Was it the football? Was it, I don't know, the marketing stunts? Those you need to know. Again, know the effects, know the causes to predict the future and then prescribe what they should do. Because every business is asking for AI nowadays. But the only way to actually help them is to stop talking AI and start talking problems, data problems. Data problems you can solve with scientific methods. And then afterwards they can brag about it on LinkedIn, saying we did AI. And this is stuff I learned during my first year of study. And you can get into data science. It's statistics, it's economics, it's math, it's neurology. And I work with all of these people, even astrology people, and some guy who knows everything about Boeings, because it's a very multidisciplinary field. And you only need to know a few of those to join in. That's the beauty of it all to me. And that brings me to my final message to you. Please try to stand out. Why try to fit in when you can stand out? LinkedIn is a great example of this. Everyone you don't excel there by doing the same as everyone else, but by doing stuff different from everyone else. Don't all study the same AI data science stuff. Get a minor in something else. My best people in my teams, and I have like 30 of them, are those who know something that the rest doesn't. So when people delegate tasks, you pick them up. When people tell you to wait, be proactive instead. When you get told not to ask questions, ask them anyway. That's how you stand out. Just like I stem from a field full of theory, I went into data instead. Bite off more than you can chew. Then chew it. That's how you learn, that's how you grow. Do connect with me on LinkedIn if you want to talk afterwards. Thank you for having me. It's all about data, and it looks cool, it sounds cool, but this is really what it looks like. Thank you. Are there any questions?
Hi, thank you for your talk. We have a question from Jordan. He said, I think it's fair to say that you have given us a lot to think about. What are some things that you think will need to happen with the regulations with respect to AI and data moving forward to strike a balance between protecting privacy and providing access to data?
Very good question. I think the main issue is that we are in a reactionary phase. Like, there is no legislation, so we start making legislation. But the vast majority of that legislation is mother may I, no you may not. It's telling you stuff you can't do, and it's about the causes and the effects, but not the mechanism. So the EU says you can't discriminate in algorithms, and it has to be unbiased, and it has to be fully transparent and explainable. Well, any data scientist worth their stuff will tell you, and all of those three are not black and white. Nothing is completely black box unexplainable. Nothing is completely 200%, 100% explainable. Nothing is entirely biased or unbiased, because a computer doesn't see the difference between hiring a person based on their education or hiring a person based on the color of their skin. Both are biased. It's just some we accept and others we don't. And as long as the legislation is made by people who only know law and can't do math, this problem will stick. We're just at the start of it.
Okay. And then for the last question, since we're running a little bit late, from Guilherme, he said, from someone coming from the technical side of things, how to get involved in more sociological questions such as bias or AI for good?
You have theory and practice. Like one major thing a few of my best data scientists did was do a minor in something completely different, like psychology during their studies, and that allowed them to differentiate from like all other competitors on the market who only knew the data side of it, but not the people side. But that's the theory part. In practice, experience is the biggest commodity on the market. I do home projects. The coffee project I just showed. I installed sensors in my plants, including the plant right over there on my phone that allow me that tell me how much water, air, light, and the temperature of the plant. So my computer screen can scream at me when the plant is dying. Here.
Oh,
The
wow.
poopy icon tells me how much fertilizer it needs. Now, I know nothing about agriculture, and I'm answering your question. I know nothing about agriculture, but I was talking to a major agriculture firm, and they asked me, what do you know about sensors and plants? And I was like, well, I know this. And that was impressive to them. In the same way, hobby projects for charity projects on the ethical side, connect to an NGO near you. They always need help. Volunteer for the Red Cross. I go teach in Ghana every year, well, over Skype connection right now for reasons, horrible Skype connections.
Yeah.
But that experience, volunteering experience, gets you so much more know-how than any course ever could.
Nice. Thank you so much. I really like that plant sensor. I think I need it as well.
My plants like it too, otherwise they would die.
Exactly. That's my problem. Thank you so much for your talk. It was very interesting. And thank you for waiting. And so to finish off, thank you everyone who came. Insights. This is the end of our virtual summits, day 2. I had a great time. Hope everyone enjoyed as well. We will do, like yesterday, a short network session in the network area. We will randomly match each attendee with another attendee, and you can have a one-on-one video chat for 3 minutes. It's really fun if you want. And I'd also like to thank all of the speakers yesterday and today. The tech support and marketing support, Ibrahim and Sebnem, for being here today. Moderator and AI Agents founder, Robert. And ELU founder, Alper. And Christella, who helped us organize the event. And then everyone who came and watched the summit. Thank you so much.